Flexing we have a GPU, are we now? Yes, I do have a GPU. I'm part of the elite. Okay, there we go. I believe we are live on everywhere now. And just like that, it sounds like Salad might want to get out of the bedroom. I think he's in the bedroom. Okay, let me just go let Salad out. I'll be right back. It was not Salad. It was Gumpy. Gumpy's not allowed to leave the bedroom. So we can't do that. Anyway, how did the corner subdivisions go? The streams you did just ended, so I was wondering if you succeeded. I forget exactly where I stopped streaming that. It's not done yet. I'm still working on that. I've just had to move on to other things in the meantime. I think a lot of the half-edge stuff kind of got interrupted last summer because, long story short, I did a lot of search and rescue stuff for lost cats. And then I got into cat photography, and it was like one of those rare moments where I got a hobby that got me out the door, which is very rare. So like I kind of just like let myself do that and try not to stress too much about work. Yeah, and so now I'm stressed about work. So the corner subdivision stuff, I think I did some relaxation things for like relaxing the geometric layout of all the vertices. There's a white flicker on stream? A white flicker. Is anyone seeing a flicker? Or is it just MemeStar that has a flicker? That might be on your end then, MemeStar. But thank you for the raid, Rothio Tome. Hello, everybody. But yeah, so for those of you who are not sure what I'm talking about, the I was working on making a bevel feature, which in 3D modeling is when you have a, let's say you have some geometry, like a corner of some sort, some geometry like this, and you select this edge of the corner and you want to make it rounded and smooth, which is very easy when you only have two faces that meet at an edge. That's a very easy case to smooth that part. That's kind of the easiest case. It gets a little bit harder when you have a corner of a cube. So if you have the corner of a cube and you select all three edges of that cube and you want to smooth that corner, it gets a little bit trickier. And then if this cube is not orthogonal, in other words, it's skew, it could be like twisted in whatever which way, right? Then solving for what shape the subdivided bevel should be can become kind of non-trivial. And this is especially true once you have more than three faces meeting, and once the edges that you have selected is not every single edge. It's like a random collection of edges that meet at that corner. It becomes kind of a tricky problem. Yeah, so I was doing that. I didn't finish that though, but yeah, I'll get back to it eventually. Right now I'm doing soft selection, and we are several layers deep into this, where it kind of doesn't seem like I'm doing anything related to selection anymore. Let me switch scenes. Let me just make sure I don't have anything private on screen. Just a moment. I wanted to thank you for YouTube math courses. They helped me a lot. I'm glad to hear that. Thank you. What language are you going to write it in? The 3D modeling tool, it's primarily written in C#, but also HLSL for anything that's done on the GPU. Are you the guy I think you are? I don't think so. I'm not a guy, so probably not. What shading language are we writing the solver in? It's going to be a compute shader in Unity, so it's going to be HLSL. Or CG. I forget exactly where Unity is on the CG to HLSL transition, but I think it's HLSL at this point. Well, yeah, the dispatch of everything is going to be done in C#, yes. Do you have a college degree? I do not have a college degree, no. Okay, so let me get everything ready. I believe it supports both. Yeah, I sort of got the impression that CG is not really a language that's alive anymore, but then there's a lot of overlap between CG and HLSL, so it's kind of like a distinction without a difference at this point, but then there's still some technical things that are different, and I'm not sure. Seems like a complicated situation. Okay. What's your occupation? So it is genuinely hard to explain my occupation at this point, but I've been a game developer for most of my life. And then since a few years back, I went to I went into doing educational content online and streaming. And then I've been doing a lot of tool development, so I'm very much within the like technical art sphere. And then I do freelance game development every now and then, and that's usually technical art as well. So anything shader related usually, which is also kind of because that's the kind of stuff that I want to do. So it's only those kinds of freelance gigs that I accept. But yeah, so that's what I do. I do a lot of educational stuff. I spend a lot of time doing. I do talks at conferences every now and then, and I put too much effort into those without getting paid for it. But you know, whatever. We do it for attention in this attention economy, or something like that. How much do you make? How much do I make? I don't know how to translate that into. Let's see. Let me. Like personally, I'm guessing personally, not my company, right? Just a moment. I never have the number in my head for how much I make in dollars per year. I just know the crowns per month. So I just don't have that conversion in my head. Okay. Okay, so my baseline, my salary is 43. Wait, that sounds way too high. Hold on, did I add a zero? Hold on, let me Okay, so that is in crowns. SEK to USD. Why does this sound so much higher in my head? Is that correct? So I make so my salary is like 38,000 crowns. Or wait, 36,000 crowns per month. So that is around $3,800 per month. Yeah, I think. I don't know how to do math. I don't do this numbers thing. I don't know if that answered your question. but yeah, that's my baseline. But yeah, so most of that income is from my tools that I make. So I'm selling a tool called Shapes. And then and then also my Patreon, and then my YouTube. So I think my tool development stuff is like, is that half of my income? It's quite a lot. I think it's more than half. And then the rest is like YouTube, Twitch, and Patreon combined. And Patreon is by far the biggest one out of those, because streaming and YouTube generally just doesn't pay very well. And also, I'm bad at like, I don't know. I don't like play the YouTube game of trying to optimize for viewership. I think if I did that, I would probably earn a lot more from YouTube. But right now, like my like prepared content YouTube videos take a long time to make, and I make like one video every 2 years or something like that. like besides streaming, right? So yeah, I've been trying to get better at like making I don't know. I feel like I need to get better at like letting go and making it sounds bad to say lower quality, but I'm really perfectionist, and it stops me from making videos. Like the last video I made was pretty much improvised because I wanted to force myself to not get stuck in the perfectionist trap. But I don't know, it's so much easier said than done. Like streaming for me is way easier, but it obviously doesn't make as much money as videos would do. But is it intended that subscriptions do not show in chats on the screen? I think I just don't have an alert set up. So yeah. I might just be missing that. Can you explain what the solver is doing one more time? It's looking for edges to bevel on a mesh. Oh, the beveling and the beveling and the solver are entirely unrelated. They're two separate problems. It was just someone was asking about the beveling stuff that I streamed a bunch of months ago. One thing you could consider is cropping bits of streams and uploading them as videos or funny shorts. Yes. It's just that I just find that kind of work really, really boring. And I just struggle so much like working on anything that I find boring or uninteresting because it's like I've just seen this because I was participating in this stream, right? And I don't know, I just find it so boring. And because it feels like a very like transactional thing, like I'm just doing it because I know that it would be good for the algorithm and good for my income. It's just like I just don't. I'm just not up for it, you know. And I should just hire someone to do this, but I also have a huge commitment issue So like whatever people might offer, I'm like, ooh, maybe I don't want to get locked into this, and I'm not sure. And what if it's not good? And then I start questioning myself like way too much, and then I end up not doing it because not doing it is the easy way out, right? Which is bad for I guess my brand and my channel and all that. Um. Mm, mm, mm. Why don't you try to create a startup? I mean, something you like. I mean, I do have my own company. It's just that I'm the only employee, right? So I guess it depends on what you mean by startup. Um, Thank you for the $10. A deep field view. What time is it for you? Love that I can watch your live streams, love your content. I am in Central European time, so Stockholm time. Are you building game engines? Nope, I do not make game engines. Okay, all right. Let's see if we can get started. All right. If willpower or money wasn't the issue, what would you want to do though? I mean, it is the stuff that I'm doing right now. So most of what I do is working on my own projects. So working on Half Edge, streaming like I am right now, and yeah, just working on my own projects. That's pretty much all I do, and I do enjoy doing that. It's just that I could go further and do certain things to make more money. It's just that that particular aspect of it is just really, really. I just super don't enjoy that. I would rather do literally anything else that I also still need to do within my company. Didn't you also participate in the beginning of NeatCorp? Yes, I'm a co-founder. Was a co-founder. I did co-found NeatCorp. I just don't work there anymore. I left a few years ago. All right. Okay. Let me get my tablet pen, and we can get into what we're doing today. Have you ever considered doing videos in the vein of Sebastian Lug? I mean, yes, I do feel like Sebastian Lug's videos, those are the videos that I have in my head that never make it out. Like, I have like thousands of videos. Thousands is an exaggeration. Dozens of videos that I sort of imagine I would make like that, but there's something I genuinely don't know what it is, but it's really hard for me to like Sebastian does a lot of content that's he kind of takes you, well, it's literally called Coding Adventure, but I think the nice thing about his channel is that he really does take you on a journey from like the discovery process of learning something and then implementing something and kind of showing every step along the way in a way that's interesting to see, kind of like the highlights of implementing something visual and interesting. And they're really good. I love his videos. They're great. But there's something that makes me not want to make videos like, I think that's it. I think that might be the issue. I think that the issue is that maybe I just don't like making videos. Like I think there are a lot of parts of that I do like. I like animating. I enjoy teaching. I like making visuals. That making visuals, love that part. That's super fun. Love doing the research. I love learning things, and implementing things. All of that stuff I love. But the actual recording process and writing a script and putting together a video, that I don't enjoy. I think that's fundamentally the issue. That I just don't like making most types of videos, you know? Oh, I just don't have the money to hire people. Like, if I could not be able to, like, I would not be able to hire someone to, at least not someone who's doing it full time. It would have to be some other setup, I think. Okay. But streaming is a pretty happy medium. Streaming does allow me to engage with the educational side of things. I like learning things, and I like explaining things, and I like that kind of interaction. And I usually work pretty visually whenever I conceptualize problems and draw stuff and whatnot. I like that part. But then there's something about the moment you go from, like, streaming is nice because the expectations are pretty low. Like, it's live content. You're not expecting every, like, second to be ultra entertaining. But when you make a video, okay, this is just perfectionist me speaking. When I make a video, it's like I'm judging every second of that video as, like, this has to be perfect. And if it's not perfect, then I'm doing a bad thing. And if you could make it better, you should have. Like, that's what I have in my head all the time. And so I think I just put the bar way too high. And so, like, the splines video took a year to make. And I don't think it, like, in some sense, I don't think it should have. Like, I think if I just made the splines video and I just did, like, instead of pushing it to 100%, if I pushed it to 80%, it would be, like, half of the amount of effort. Like, that last push is so much more effort. And yeah, so, like, yeah, like Trevor is saying, like, I would rather not make a video than to make a bad one. And that's the problem. I should be okay making a video that I consider bad, because most people wouldn't say that it's bad. Like, that's just me. That's just me saying it to myself. This is not feedback I'm getting from people in general. Like, even my like AI video was improvised, and it had, like, audio issues and everything, and, like, nobody cares about those issues. I'm the only one who cares about it. And so it's my own, like, shitty hang up of like, if my art is bad, that means I'm bad. And I hate that connection. I don't know how to break it apart from, like, practicing it, I suppose. But I don't know. But yeah, it does make me think that, like, whenever I work on an interesting problem that's visual or whatever, it's like I should just hit record. I should just hit record every now and then to record whatever it is I'm working on. So that I have a bunch of clips from the things I'm working on. And then I could put together a video like Sebastian does on his YouTube channel. But immediately I get obsessive over, like, okay, but if I record for a prepared video, I can't be using OBS with the same settings that I use for streaming, because streaming is lower bitrate and I need to record at a higher bitrate. So I would need to set up a profile on OBS so that I could record at a higher bitrate, but then I need to remember to switch to that every time I want to record something. And then, like, it just piles up and it becomes more and more, like, the barrier of entry to all of these things becomes bigger and bigger until I just don't do it at all. Yeah. I think Sebastian codes it all up and then records afterwards. I don't think, well, I could do that, but then that's more effort, I think. And that's scary. Perfect is the enemy of good. Yeah, exactly. I wanted to know whether you're interested in AI and machine learning. No, I am not. I am very much, I'm generally anti-AI, so. Okay, all right. Let's see. Should we get started? You can put those clips for Patreon subs probably without editing. Maybe? I'm not sure. To be fair, with so much soulless AI-generated content and scripted material out there, I find imperfect content much more human, easier to follow, and easier to relate to. Yes, I have thought about that as well, that there's a certain, like, soullessness that comes with high fidelity. and AI is kind of a fidelity shortcut. So yeah, I mean, you're completely right. But anyway, it's a mental hurdle. It's just a mental issue. It's all in my head. And I don't know how to escape it. Unfortunately, I'm trapped in my own brain. Where's Photoshop? There it is. All right. Zoop. Okay. So what are we doing? What are we doing? What is happening? Okay, so zooming out. I am making a 3D modeling tool. So, you know, a regular 3D modeling tool where you have a bunch of vertices and faces and you're constructing this triangle mesh. Sometimes, you know, polygonal stuff doesn't have to be triangles and so forth, right? And I would like to implement something that's called soft selection. In other words, if you select a vertex and move this upwards, a soft select feature would make it so that depending on how close other vertices are to this vertex, they also move a little bit upwards. And the further away it is, the shorter the distance they move. You might have like a radius for this soft selection. So it's kind of like almost like a brush where you can kind of set the size of the brush, except it's for a selection system, not a painting tool. Kind of like a terrain tool, yes. So that's what soft selection is. So then there needs to be some kind of function for the distance to every other vertex. So given your selected vertex, which is this vertex in this case, given your selection, you want to know what is the distance to every other vertex. And there's kind of two different ways of doing this. Well, there's multiple, but one of them is just kind of like getting the Euclidean distance. Like you just literally take the positions, subtract, and get the magnitude of the vector, and then you get the Euclidean distance with this yellow vector here, right? So you just grab this distance for all of these. And then the distance that you move these is going to be a function of the magnitude of all of these yellow vectors, right? But you don't always want to actually use Euclidean distance, because sometimes you might have a case where, let's say we have another mesh here. Let's say it actually goes down. So it's kind of like a U shape that's lying down on its side. Like in this case, if you select this vertex and you move it upwards, sometimes you don't actually want to use the Euclidean distance because this would be a very, very short distance. But maybe you actually wanted a different kind of distance. Maybe you wanted to use the distance along the surface. So the distance to this one, instead of just grabbing the Euclidean distance, maybe you instead want the distance along the surface, which would kind of crawl along here, right? So maybe you wanted that instead. And I think in most cases, this is what you actually would prefer. Because you do kind of want to have like, usually it's like, I want to create a bump on this location in the mesh, but then the other geometry all the way over here feels unrelated. It feels like it's not supposed to move. In some cases, maybe you do, but that's there are different use cases for both, of course. So basically this would be the Euclidean distance. And then this green one would be something known as geodesic distance. So computing geodesic distance is actually kind of non-trivial. And that is basically the problem that I've been looking into. And there's a lot of steps to this, because I wanted to try to implement a specific method of doing this, known as the heat method for geodesic distance, which involves differential geometry, at least if I want to like actually understand every step along the way, which I generally do. Because there is kind of a brute force way of doing it. You can do like brute force pathfinding on your triangular mesh. But the problem is that doing that when you have a lot of source points, in other words, your selected vertices, when you have a lot of sources selected, let's say you have a mesh with 10,000 vertices and you've selected 4,000, like doing pathfinding, to and from every single one of those vertices is kind of rough. Like ideally you wouldn't want to have to do that, especially because pathfinding is usually involves a lot of like caching, like adjacency things, and it's not very parallel. It's usually pretty serial, and that's an issue. And so I wanted to try to find a way to do this in pretty in a pretty parallel way, because usually when you have dealing with mass amounts of data, like when you have a mesh with thousands of vertices, that's a lot of data, and you want to do processing on those. Like doing that on the CPU is usually not a good idea. Usually you want to do that on the GPU, and then you're going to be able to do so much more in parallel, and it's basically going to be real time instead of taking, a second to compute a certain thing. Yeah. So that's geodesic distance. Oh yeah, like someone mentioned, geodesic distance is not always along the edges, which is part of why it becomes complicated. Because if it was the case that geodesic distance was always along the edges, it would be kind of like a graph distance rather than like a spatial distance across the surface. But if you consider, for example, the distance to this vertex, I believe that would be a path kind of like this. That would kind of cut slightly diagonally there. Like that. And this path is a lot less trivial to calculate. Like if you just used vertices and edges, this would not be that much of a problem. It would be relatively easy. But geodesic distance gets more complicated than that. Okay. You should just excuse me. You should just record whatever you're drawing and then have all the animations for your videos for free. I know, like that's like, yeah. It's just it would be so easy. It's just that in my head, if it's a prepared video, I should do better than that, because these are just like scribbles. But if it's a prepared video, I should animate everything and make it shiny and perfect, so that I'm not perceived as imperfect, And yes, that's stupid, but I don't know how to fix my stupid brain. Try it once with a recording. If it's not good enough, stop it. That's the thing. Like, I perceive it as not good enough, regardless. So, Is it calculated as such because you need an extra point of reference to show its relation in space rather than linear distance? Kind of like a triangulation on a sphere. I'm not sure what you mean by that. Anyway, so there is a way to do this, to get the geodesic distance that is known as the heat method. So it involves 3 steps, pretty much. So if you sort of presume or pretend every point here is a vertex, then the heat method involves a few things. So the first step is that you kind of treat your selection as a heat source. So if you imagine this being your selected vertex, then you diffuse heat, or kind of like simulate heat, across the entire mesh. So this is kind of the diffusion step. And this is kind of a weird fact, but if you diffuse heat over a mesh, and given some kind of time step, because you know the heat would be different depending on how far forward you go in time. The closer that time step is to 0, the closer the gradient will point along the shortest geodesic distance, which is a pretty weird fact. It was kind of unexpected to me. So if you just like imagine like putting a slightly warm thing on something that's very cold for a fraction of a second, and if you're able to measure temperature differences across the entire thing, the gradient of this field would point along the shortest geodesic distance. So you kind of get this vector field from that. Would that just be the principle of least action? Potentially. I'm not sure. I don't do a lot of physics, but it's maybe. But yeah, so then you get a gradient field, and then you normalize those vectors, or you normalize that vector field, and then you integrate over that vector field to finally recover geodesic distance. Yeah. I know it works, but doing a whole heat simulation for calculating a distance feels so wasteful. Potentially, but there are advantages with this method. And one of the advantages is that it's very parallel. It's very parallelizable, which is a huge advantage. There's a lot of algorithms that are fine for like small amounts of data, but once you have like thousands of vertices and thousands of sources, like you really do want to be able to take advantage of parallel algorithms. So I think that's where the GPU solvers come into play, which is what I was going to look at today. Because the 2 steps here, or the 3 steps, the first one is a linear solve. So this would be solving the, I think it's a Laplace equation, something like that. Some kind of solver for that. And then I think solving this one can also be formulated as a linear system. And then the middle one is just that's just a single operation. So that's basically free. Yeah. Last stream, I was losing my mind, trying to wrap my head around I guess linear algebra. I just haven't done like someone asked earlier this stream if I studied at college. I don't have a college level education, so I never studied linear algebra. So, and so like solving a system of equations is just something that I've just never really done, apart from like 2 equations in high school. So I've sort of been trying to wrap my head around the whole process for how to do bigger systems and how to deal with sparse matrices and adjacency matrices and the Laplace matrix and all of this stuff. Yeah. Yeah. Only to then kind of find out that, oh, well, usually you just use a 5-point stencil and call it a day, and use simpler solvers than the more complicated solvers. But anyway, is that a good method to use for a flow field for a lot of units navigation? It could be, yes. If you're making an RTS game with a lot of units, then it could be. Yeah. So I was implementing I did implement the conjugate gradient method. I did the conjugate gradient method for solving matrices, and I implemented that on the CPU, and it was very slow. It worked, but it was very slow because I didn't do any like optimization apart from some like very, very simple things. And so between last stream and this stream, I started looking into just like cleaning up my code a little bit, but mostly just moving things over to the GPU. And so I actually have a much faster solver now. So I'm going to show you what that looks like. It used to be like if I set the texture to like to a size of like 12 and I set the number of iterations to 4, my entire computer would lock up for like an hour. But turns out part of why that happened was because I was printing the matrix, and if I have a 12 by 12 data set, or let's say I have a 10 by 10 data set, that means I'm going to have a 100 by 100 matrix, and I was printing that matrix. So if I cranked up the width of the thing to like 128, I was trying to print like a huge amount of text. And that didn't really work. My computer didn't like that. So I clearly told it to do stupid things. But now I've changed the solver to not be a conjugate gradient. Now it is I always forget. I don't know the difference between Gauss-Seidel and Jacobi iterations, but it's one of them. I think it's the Jacobi iterations. So I'm doing that on the GPU now. And now the speed is a lot faster. So I set that to 0. Set the resolution to 128, something like that. And then if I hit refine, actually it's hard to see. Let's lower the resolution a bit. So now if I click refine, it's now trying to solve for a 0 Laplacian everywhere. So it's gonna try to create a harmonic surface given these known data points. And so this is now on the GPU. And so what I can do is that I can just say, okay, I'm just going to do this on every frame. And it is so much faster. Like this is thousands of iterations already. And so now it's kind of found the minimal surface for this. And I can kind of like just move these points around. And you can see that it's solving immediately. And so this is what I mean when I say that doing things in parallel is violently fast if you do it right. You know, GPUs are very, very, very fast actually. Yeah, so now we have the goopy little surface. But it's a little bit slow. Like you can see that it's taking a while, and I wouldn't want things to take this long. And so I've been considering like if I should look into like if I should either optimize this, like if I should either optimize this particular case, or if I should actually start trying to implement this in the 3D modeling tool already. But it feels like I'm not entirely sure if the way that I'm solving this right now is applicable to a non-grid layout, because right now I'm using a stencil for I'm using a stencil, right? And that's assuming a grid, but I can't really do that for an arbitrary mesh. Yeah, so I'm not sure, but maybe I can use this type of iteration anyway. I'm not sure. Yeah. Okay. But there are ways to speed this up. So for example, if I disable the auto refine, like I could start out with just flat values like this. But I mean, I can also just try to find an approximation for what I like, getting something close to the final solution, and then I start iterating. And there is a yeah, so I was trying to figure that out in Desmos. So I was trying to figure out like, okay, given a set of points, can I find something that looks close to the actual solution? And this looks kind of close, right? Let's see, do I have my parameter here? Okay, let's put it back. And I have this parameter for kind of tweaking how it should handle these points, like, or like what the fall off should be. Because this does not have 0 Laplacian. So if I visualize the Laplacian, you can see that it's clearly not 0 near those points. Yeah. But this would be a good starting point. So this is kind of just like, this is just like taking a fall off from every point and then combining them with a weighted sum, pretty much. I did also find it kind of interesting that if I like crank up this exponent, or no, sorry, not that one, this one, really high, you just get a Voronoi, which I guess I just didn't expect to get a Voronoi just by increasing this exponent to like a really high number. I don't know. I mean, it sort of makes sense that you would get something like that, but I just didn't. I just wasn't expecting it. That was a happy surprise. Okay. So I can use that to basically create a good initial guess. So I implemented that same function here. So this is the Voronoi. And I can set the exponent to whatever. And then I can just refine from that point onward. And yeah, kind of seems like an exponent of like 1 here is pretty close. So 1, and then auto refine. So it's a good way to get like an initial guess, and it shortens the iteration time quite a lot. But yeah, I do feel like it is surprisingly slow if I set the resolution to something like 1024. So here, it really takes quite a lot of time for this to propagate outwards and make its way out to the edges and all of the extrema. And so if I were to speed this up, I believe the usual strategy for doing this, what was the name for it? Something grid, I think, maybe. The idea is basically that multi whatever. The idea is that you can basically do a solve on a lower resolution variant first. Like, I don't know, this is 16 by 16, or this is 8 by 8. So this is super low resolution. Like, solving it for 8 by 8 that's really fast. Like, there's not that much data. I don't need that many iterations, right? And then I can take these values and kind of project them or interpolate them across something that's twice the resolution. So 16 by 16. And then something that's then take this projected onto a 32 by 32 and so forth. And then work my way upwards to whatever the actual resolution I want to have in the end. And so that is a way to, like, you can kind of get the coarse grain, like, low frequency stuff to spread really quickly. And then you can do the, like, fine grain detail stuff later, which is kind of the idea of doing it with this, like downsampling and upsampling type of stuff. Yeah. But I don't know if that's applicable to my actual use case. It would be useful for this use case, because here I'm on, like, multi-scale. Yes, I think so. Multi-scale, multi-grid, I think. Yeah, multi-grid. It's called multi-grid solutions. But I don't know if multi-grid stuff is like actually useful for my use case, because my data is not arranged in a grid anymore. It's a mesh, right? So I don't know if I can use that. Yeah, so either yeah, either I can play around with optimizing this further, which seems like fun, but it doesn't seem very useful. Or I try to start putting this into half edge directly. I think it would be good to put it in half edge, but it's probably a less interesting stream. Or maybe that's not my problem. Maybe that's your problem, you know? How do you generate the matrix for the solver of a general geometry? So mathematically, you would basically create an adjacency matrix, which for grid stuff looks like this. You kind of have this like very diagonal matrix, and so it basically says so this is every vertex. This is also every vertex, and it basically says whether or not, you know, this vertex is adjacent to this vertex. It's 1 if it's adjacent, and it's 0 if it's not. And so we can see that given these two, we know that vertex 0 is connected to both vertex 1 and vertex 3 because it's a 1 in both of these cells. So that's, you created an adjacency matrix using that. And then you can kind of plug in whatever equations you want to solve for. So if it's like a Poisson equation or whatever, you can plug all of that stuff in. And then you do a whole ass solve. But it is also a little bit tricky because if the number of vertices you have is 4,000, like, are you really going to have a 4,000 by 4,000 matrix? Probably not, right? But I believe there's gotta be a stencil equivalent to on triangular meshes. That's gotta be possible, right? It would just be that it's just that these connections are not necessarily 4. It's just that it could be, you know, 2 or 10 or whatever. Yeah, so I feel like it would just be, I feel like you can still use the stencil method for this. And also avoid having to like explicitly construct the entire matrix. So it would rather be that you store the degree. So 4 is the degree. In other words, the degree is the number of edges outgoing from a vertex. So that would be the thing you multiply or divide by, depending on which equation you're currently looking at. Yeah, so it would just have degree numbers of connections. And then I feel like it should just work. I feel like this should be possible. Most of the matrix is 0 though, so sparsity calculation comes in handy. Yeah, I'm just not sure, like, for a grid, this is deterministic, so I don't even need to store the matrix. I can just make that a function. But if it's, like, yeah, even if it's sparse, I'm not sure how to store that data in a way that's efficient. I don't know. And it feels like the whole, like, this whole way of phrasing it and like presenting it, I feel like this is solely a tool used for like putting your equations in this form so that you can use like existing solvers for that. But otherwise, this whole matrix is kind of an unnecessary construct that just takes up a lot of space. If you imagine actually storing all this data in a 2x2 like data structure, or 2x2 n by n data structure. Yeah. Okay. Yeah, I think I actually do want to try to get this into a half edge. I think I can play around a little bit more with this thing, but I think ultimately I think I need to actually get into my actual use case, not just because it's more useful, but also because I need to get it working at some point. Because I also have a talk lined up pretty soon, and it would be cool to actually show it working in half edge. As you modify the mesh, the areas and distances change. Are you taking that into account? No, I don't think I want it to do that, because then you kind of get a, I don't know, it kind of becomes a whole differential equation situation. A talk, yes. I'm going to give a talk about half edge and basically go through some of the stuff that I've learned and some of the things I've struggled with working on half edge. And that's going to be at, I think it's called Spillkonventet in Norway in a few weeks. 3 weeks? 4 weeks? 3 weeks? Something like that. So I'm going to be talking about half edge there. It will be recorded. The venue will record it, and I'm gonna bring my own camera as well, just in case, as a backup, or a second perspective to make it like super cinematic. I don't know, but I will be recording it, and so even if you're not present at the event, it will exist on the internet somewhere. Okay. All right, so let's actually open Half Edge. I do want to try to get this into my actual 3D modeling tool. Hello, Thor. Hey. Thor has come to bother us. Yeah. You want to talk to chat? Yeah. Basically finite element analysis. I think so, yeah. I don't know exactly the definitions of finite elements and all of that, but like, is finite element like anytime you have a discretized set of data, or is it more specific than that? Wait, why did it? Oh, wait, I started... Oh, I think I started refactoring a few things. Oh no. Oh no. I might need to shelf those changes. That is not the project. Where is Message? Okay. Blue noise. That's unrelated to my current issue, so that I can commit. There we go. Oh, the version control software. This is Fork. Okay. Okay. Don't think I need. Oh wait, that one. Maybe this one. Sure. And the scene. Why not? You like Spoon more? Oh. I haven't seen Spoon. Okay. Fixed or added dithering to the skybox. Wow. And then I guess I will shelf all of this. Actually, these don't really matter. I can probably just include those. And this one is completely unused. Okay. Handles stuff. And clean up, I don't know. Something like that. And then we stash all of these. Stash. Message. This is input or viewport, input, refactor. Zoom. Okay, can I use this now? Wow. It works. So, this is my 3D modeling tool. It does not have soft selection at the moment, so that's what I'm gonna be implementing. I wonder if I should maybe start with Euclidean soft selection. And then I do the geodesic one afterwards. I think that's a good idea. Because then I can like get all of the infrastructure in place around the actual math. And that's also significantly easier. Okay. Where would I put that? I feel like it would kind of belong up here, but it's more so that these two don't really belong up here. Doesn't super matter. I'll just add it wherever. Because it should not be a tool, because then you can't use other tools at the same time. Although, does that make sense actually? Do you ever want to have a soft selection and then press a tool? Or like an action? Does that make sense even? I guess maybe it would for certain actions. And like any action you can scale by some amount, I guess. Like, can you multiply this action by a real number? Does that make sense? Maybe. I guess I'll just start with transformations. Okay. So, let's see. What do we need to do this? We need... let's make a literal list. Soft selection. Okay. What do we need to do? First step, I believe, is that we want to have some way of activating it. A button, hotkey to activate soft selection. And then for setting the soft selection radius, eventually I'm going to have a UI for that, but that's like, doesn't really matter right now. Okay, and then I want to be able to visualize it. So instead of vertices just being fully selected blue, I'd probably make it so that unselected vertices are just gray or kind of dark instead. And then do a gradient for the selectiveness of every vertex. So I would need some way to just generate the or compute and store the minimum distance. No, it's a distance field. The selection distance field. That's what we're gonna call it. Oh wait, that's also short for SDF. God damn it. Ugh. But it's, yeah, I'll just call it selection distance field and never shorten it to SDF. Weight per vertex. Yeah, framing it as a weight is, well, I don't think I want to store the weight. No, the weight happens afterwards. The distance field is the complicated part, and the weight I can do real time. So, and then I want to visualize the soft selection distance field. Okay. I think that's a good start. And then, oh yeah, and then the actual manipulation. Actually use soft selection during manipulation. Which is going to be hard for rotations, because I think I broke my rotation gizmo. Yeah, my rotation my rotation gizmo is broken, so I can't really use that one. But we got translation. And do you really need anything but translation, you know? Aren't rotations just composite weird translations anyway, when you really think about it? Cool. Okay, so button to activate soft selection. All right. Now, as we all know, the first step in doing anything like this is to draw the icon for it. Because this goes under selection actions, right? What the heck did I just do? Let's see. Selection actions. Okay, soft selection is a very like bell curve type of deal, I think. I don't know. I don't know how to draw a bell curve. It's a tilde instead. I feel like I don't know how to stay within bounds. Also doesn't super matter. There we go. That one's okay. I feel like I should have something a little bit more descriptive than this. But it's such a small icon, so I don't know how much information I can get across. This is probably a good start. I feel like I want something to kind of like communicate your actual selection, because now it's a little bit I don't know. I almost want to like fade this. Well, I guess I could. Like I could do something like, why does control click not take me to the layer? What the heck? If I control click, why does that take me to the group? Do I have a gray? Yes, I do. Does it not bother you if an icon is not that pixel perfect centered? No, it does, but I try to learn to not get too bothered by it because this one has an uneven amount anyway. So like, how am I supposed to adjust this one? It's literally impossible. So that one is just over. This one is a little bit more for 4, but then it turns into 5 at the bottom, so it's impossible there too. And you know, it's just going to be too much. Okay. Where? Let's see. I need to disable the background. And I need to know where to put this icons. Over here. Zoop. Okay. Okay. Wait, I don't want to save slices. I want to do save a copy. PNG? Where's PNG? There we go. There we go. Okay. Back into Unity. Refresh. That's not what I wanted to do. I wanted to open this. May I ask what is a GPU solver? Basically solving systems of linear equations, but on the GPU. Although now I've sort of skipped over that part. But this one, for example, is solving a Laplacian function. We're solving a Laplacian over a height field. And it's doing that on the GPU. So this is the computations that are happening that are like changing the surface. All of this is on the it's being done in a compute shader, so that's done in the graphics card. So that's what the GPU solver is doing. You solve the equations using matrix operations. My old implementations did conceptually, but the current one, this one on the GPU, this one is just a Jacobian finite difference situation. Okay. I don't know. Yeah, I don't know if I'm gonna be able to use like a Jacobian for my actual distance function. What am I gonna call this one? Icon, action. This is not really an action. This is a selection. I'll just call icon soft selection. Did you finish your geodesic distance thing? I am several layers into it, and not done with it. That's what I'm working on right now. Is a GPU solver deterministic on different GPUs? Depending on how you write it, but generally, yes. Different platforms deal with like nans differently. Like, I don't know, iOS Metal, I think, treats nan different from some other like Windows platforms. I forget exactly all the differences there. But assuming you have well-formed floating point operations and they all follow the standards for floats, then it should be the same. But who knows? It's a jungle out there in terms of different graphics cards. Okay, we have an icon for soft selection. And now, where's my assets? Assets, there we go. Icon sprites. Need to add. Where's soft selection? There it is. There we go. Oh my god, getting 2 questions at the same time from YouTube and Twitch. What is a GPU solver? I feel like I just answered that question. It's solving a system of linear equations, but doing it on the GPU instead of CPU. Maybe I should change my stream title because I'm not really writing the GPU solver right now. What do I change the stream title to? Implementing or soft selection implementation. Soft selection implementation in... I can't really call it half edge because nobody knows what half edge is because it's not released yet. All right, hold on, adding soft selection to my 3D modeling tool. There we go. I should probably change it on YouTube. Can you change stream titles on YouTube? Is that a thing? Edit. Okay, there we go. Wow. Solving the eternal question. What is a GPU? You know, a GPU is just a CPU, but there's like more of them. And they're weaker, but they are many. That's it. All right. Let's see. Where are we? I had a checklist. I forgot the most important one. Create an icon. There we did this. I can check that box. Okay, button to activate it. I guess I'll just toss it into this top menu here. I think that's probably easiest. I've forgotten how I wrote my UI. Let's see. Is it in the viewport UI? Viewport panel. This sounds relevant, but this might be one layer below. This is not the one that I clicked. There we go. Right, so we got the viewport panel. Where am I using this? Okay, so maybe I did this UI with the UI builder. Let's see if we can find it. Okay. I wonder if I... Oh, okay, right. I made it like an enum button thing. Okay. I get it. Okay. I'll just duplicate that. So this is going to be the enum button for soft selection. And the icon is going to be soft selection. Okay. And so then I think I can just... So why is the CSS all wonky? I don't remember it being like this. Anyway. Okay, enum cycle, soft select. And then swap this to soft selection. Okay. How did I hook these up? I'm guessing I did that in code. Doesn't look like I have any automatic hookup stuff here. Okay, save. And then toolbar top. What did I call it? Toolbar. I'm lost in my own code. Let's see. UI controls. UI utilities. UI panels. You know? Where is everything? Action panel? No way I put it in action panel. That is... no, those are the actions on the left. So that's all of that. But where the heck did I put all of the... Where did I put all of the overlay buttons? Actually, I can probably just look in the UI. Because that is actually probably a toolbar. Let's see, toolbar, viewport, display. All of these are just visual elements. Wait, so is that actually part of the viewport? Oh, wait, there's a viewport element that's separate from... Oh, okay. Okay. Oh, no. Oh, wait, what? No. That is this thing, though. Okay. Well, I didn't want to look at the generated code. Or no, wait, I'm being stupid. If I just search for this string, I'll find where I'm using that, I think. I would have thought. Viewport 3D state. Yes. This is where it is. Okay. Okay. Cool. So we make an enum for a soft selection state, off, and then on Euclidean for now. So we got soft selection, use soft selection, and then I want to hook up the UI. So that was not the string that I wanted to paste. I wanted to paste that one. And use soft selection. Should probably be it, I think. Let's see. What's the Obsidian plugin for those multiple colors? Multiple colors? Oh, the stuff at the bottom? I don't remember. But it's a way to do like to mark text somehow. I've forgotten the shortcut. I don't use it too much. Colored text. That might actually be the name of it. Wow, look at this tiny button at the top. We can toggle it on and off. Isn't modern computers the marvel? Cool. Wow. Tick that box. I'm gonna have some water to celebrate. Little bow button, exactly. Okay. Compute and store the selection distance field. How would I? No, you know what? I'm just going to do this on the CPU for now. So it's going to be a lot easier. We're going to do it with a multi-threaded CPU job, I think. Because this is kind of annoying to do on the GPU. Yeah, we're going to do that on the CPU. Okay, so there's, let's see. When you do that on the GPU, will that run in a compute shader? Yes. So there's kind of two, or there's, I can actually just explain that. Why not? The tricky thing, so we have a gazillion vertices, right? A ton of vertices in a mesh. And you can sort of arrange them in you can conceptualize it as a matrix like this. And it's going to be a triangular matrix pretty much, because Euclidean distance, every distance, all distances are mutual. I think maybe that's like the definition of distance. As in, we don't need to distinguish between the distance from vertex 0 to vertex 1 and vertex 1 to vertex 0. So we don't need to distinguish that, right? So we can kind of just like ignore everything below this diagonal here. So all of this stuff we don't have to care about. Actually, we don't need the center diagonal either, because that's going to be 0 on all of those diagonals. So we can ignore that as well. So all of these, useless. Okay. Yeah, so basically we need to fill out the distances between all the vertices. So it's kind of an n squared type of situation. So I'm trying to think. How would you do that? Okay, so I'll just try to think out loud. So we have some distance values in each of these fields. Who knows what distances will be here. But then we want... Well, that's not the final step. Because... Hold on. I want to use blue for something else. So let's say you have vertex 2 and vertex 5 selected. I want to get the minimum distance from... Yeah, I want to get the smallest distance from every vertex to your selection. So I guess, let's see. So for vertex 0, so distance from 0 to 1, is that even relevant? No, I don't need the distance from 0 to 1, right? No, I don't. Okay, hold on. Yeah, so this would be... This would just contain your selection. Nothing else matters, right? On one of these axes. I think. Unless I'm being stupid. But yeah, no, those distances don't matter. Yeah, it's just your selection. Okay, so, or no, we still need all of the other, I'm guessing what we need to populate is that we need to populate the kind of bouncy diagonal here. So these are the values we need? Let's see, 2 and 0, 2 and 1, 2 and 3, because 2 and 2 is 0. Or no, wait, this would be 1 and 4. No, that's not correct. No, we don't even have a diagonal here, right? It would just be all the values straight down. Yeah, that would be it. Okay. Okay, let's rethink this. Question is, do I maybe want to... Okay, I'm gonna keep all the other vertices there just to try to think about this a little bit more. I'm just trying to think of like data layout stuff and memory things that might need to be taken into account. Okay, so we need the distance from your selection to every other vertex. So there's going to be some distances here. It's going to be 0 here. And then we have 5, which is 0 here. And then after that, we want the minimum for each of these. Yes. Yeah. So that's going to give us a value per vertex. Yeah, okay. Okay, that's it. The reason this is a little bit annoying on the GPU is because GPUs, it's a little bit annoying to do this minimum step. Because GPUs are fastest when they can work in parallel. But if you don't parallelize, they can be kind of slow. But it is possible to do it. It's just that you need to use something called a like whole reduction thing. So like it's trivial in this case, but if you imagine I have more selection, like this is going to be like, it could be hundreds of these like blue columns, right? But in parallel processing, to do the minimum, usually you would do something like, if you have your, let's see, let's do 8 entries. So if you're doing this on the GPU and you want to get the minimum out of all of these entries here, in order to like take full advantage of the parallel processor stuff, you would usually do something like you take these two, get the minimum of those two into some cell, and then you get these two into some, well, it depends, the structure really depends on how you want to set it up. I get the minimum of these two, take the next pair, and so forth. So you're kind of like reducing it in half. So you get kind of a log O of log 2 the time computation time or whatever. So you do like a pairwise minimum of all of these. Wait, are these pairs? They're not pairs. We're missing. We shouldn't have this one here. Off by 1 errors. And then you just like repeat the same process. So you then end up with 2 things. Usually you don't actually go down to this granular level. Like if you actually have 4, you can just do this on a single kernel. But if you imagine this, but with like thousands of elements, then doing this is usually the way you would go. But conceptually, the idea remains the same. So then here you end up with the actual minimum value. This is usually not how you do it on the CPU. On the CPU, like you can just do a minimum, like one thing after another, just like straight up. And that's usually the fastest way to do it. But on the GPU, you kind of have to make use of parallelism once you have like thousands of data points. And so that's where it really shines. I assume there's probably some science to picking the minimum size after reduction. Yeah, that probably depends on the hardware and how you design your data. And there's like, I mean, there's another way you can do this as well, where like, instead of storing it here, maybe you instead store it in a sparse way, kind of like this. I remember reading about this, that there's like a trade-off of doing it either like this or like this. And both of them are fine. They both work, but they have different performance characteristics. I think there's something about like memory locality and all of that, like caching and warps and yada yada yada. Yeah, it feels like this one would be faster because it's less crowded. Because this one doesn't have to read from data that some other thing wants to write to. Wait, yes, that's actually it. This one is actually not even possible. I don't think you can do it this way. Yeah, because this one might have a race condition. I think. I'm pretty sure you have to do it this way. Because otherwise, if you do it this way, it does run the risk of these changing the value here before this one gets to read it. And then you would get issues. You could do it this way if these are separate buffers. So if this was one buffer A and this is another buffer B, it's very, very, very common to have this kind of thing in shaders where you have two buffers that you swap between, so that you never have this like race condition issue of like trying to read from some data and then something else changed it while you try to read from it or whatever. But with this layout, there's no risk for that happening. So I think this one is better if you just want to use a single piece of memory, because any pair only ever writes to something that it has control over. It knows when this is going to happen, right? So this one is really good if you just want to use a single buffer. But otherwise, you might have to use multiple buffers to do this. Yeah. Is GPU memory also managed by the OS? I don't know what that means. I don't know what you mean by managed. It sounds like the answer would be no, but I'm not sure what you're asking. Oh, it would let you do it in place too, right? It would let you do it in, yeah, it would let you modify the stuff in place as long as if this is a compute shader and if this is marked for both read and write. Yeah, I think the only thing you have to be careful of is that you have to put a synchronization barrier here. So after every step, you would need to make sure that they're synchronized. But that's mostly like, it kind of depends on how you set up all of these dispatches. Because if this is a compute shader dispatch and this is a separate compute shader dispatch, they're usually ordered in a way that you don't have to think about that. But if you set it up with where like you have multiple of these steps in a single compute shader, and then within that group, you want to make sure that things happen in a certain order, then you need to use like group synchronization points to make sure that all of these operations have finished before it moves on. Yeah. Basically, getting the minimum of a bunch of values on the GPU efficiently is more complicated than on the CPU, because on the CPU, you just like linearly running through the whole array is usually faster. Like even in some cases where you might want to try to implement something like this, quite often it's not even faster. Like just linearly getting the minimum of something, the CPU is really good at stuff like that. But yeah, anyway, I need to go to the bathroom, and there's also a cat scratching on the bedroom door, so I'm gonna see if Salad wants to come out of the bedroom. So I will be right back. This is salad. He doesn't know how to hold on to his own weight. Okay. Okay. Ow. 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 Claws, buddy. This would have to be in multiple passes either way, right? Would it be better to group into, say, 8 or 16 instead of 2 to avoid overhead of more passes? Yes. There's, yeah. It's a whole science of trying to figure out, like, exactly when to do things within a single kernel and when you should split things up into groups within a single kernel and when you should be using entirely separate dispatches of compute kernels. I don't know exactly where and how to draw those lines. I think the real answer is that you should just try a bunch of them and then you profile and then you pick whichever one is the faster one. But I don't enjoy profiling, so I just try it out and see what seems fastest in my use case on my machine. Okay. I assume GPU drivers manage the memory. Probably. I don't exactly know where to draw the line for like managing and not managing. Like, yeah, I don't know, but probably. Okay. So what am I actually doing? I have a bunch of sources. I want to get the distance between them. I don't know if does Unity's job system have atomic floating point minimum operators? Unity job system atomic minimum? I'm guessing it probably doesn't. I think usually atomic operators are like integers. Oh. Wait. Well, it's not really intrinsic. I want to have atomic stuff. Hmm. You know what? Maybe I'll just do a naive implementation of it and then it'll be slow and then I'll fix it afterwards. What's an atomic? It basically means that if you have a multi-threaded system, like for example, in this case, like if you want to find the minimum of a bunch of different values, you might want to multi-thread so that, you know, each thread is getting the minimum of like, I don't know, 32 different values in your array of a gazillion values. But then you might want to write, instead of doing this hierarchical evaluation thing, maybe you actually just want to write immediately to a single piece of memory. And so there is something known as atomic operators. So like if you want to do like an atomic add, that an atomic operator ensures that, I believe it is that the fact that like when you want to add to a thing, it ensures that you don't get any weird shenanigans happening with multi-threading where, because if you have a, let's say have some piece of memory and you have the value 3 stored or 2 stored in a piece of memory, and then you have a multi-threaded system where, or wait, if we're doing minimums 2 is a bad value. Well, let's say 10. So if you have some memory, you have the value 10, and then you have 2 separate threads that want to store the minimum between its own values. So maybe this one is reading a value of 5, for example. And then it wants to check, like, is 5 less than 10? If so, store the value 5 in this piece of memory. And so there's kind of 2 steps in that process. Like, one of them is to retrieve the value from the memory, so that you can actually check, like, is 5 less than 10? And if it is, we want to store the value 5 here, right? And that's all fine, all well and good. But then let's say you have another processor who also wants to change this value. So maybe this one has the value 6, and it wants to do the same thing. It needs to retrieve this value, check if it's less than that value, and if so, it wants to store the value 6 in that piece of memory. If you're not careful, a lot of these operations, because it's parallel, they might happen out of order. So it could be the case that, you know, this one grabs the value 10, and then this one grabs the value 10, and then writes the value 5 up here, and then this one, because this one still has 10 in the thing that it was reading, and it wants to store the value 6, it actually swaps this 5 out with a 6. Which is not what we want, right? We want the minimum. And because we're doing things in parallel, the way the memory is like read and written to, we have to be really careful about that, right? And so an atomic operation is an operation that ensures that this doesn't happen, I think. I'm pretty sure. I haven't done a whole lot of multi-threading, but I'm pretty sure that what that means. Yeah, so if there's something known as like an atomic add, it's the same thing, but instead of checking a minimum, it just adds to it. Atomic operator locks the memory path during a read, modify write cycle for a single operation, so you can't have race conditions between simultaneous execution paths. Exactly. Yeah. And in our case, we do want to have a minimum, but I don't know if there's an atomic floating point minimum. But maybe we can get away with not caring about that. Maybe that's okay. Hey, what? Boys? What you doing? They're a little feisty up there in the cat tower. What you doing? You two boys okay? Yeah? Okay. Okay. Is it on CPU or GPU now? This is just a general concept. I think there's atomics on both the GPU and the CPU, I believe, but usually, from what I remember, atomics are very limited, and there's only a very like select few things you can do. So I think like a floating point, atomic floating point add, I don't think I have access to that on GPUs. Maybe I do? I don't know. Um, um, mm, 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 mm. All right. Anyway, so we need to do our distance calculation. How would we do this? If I have... Is it reasonable to store the pairwise distance for every vertex? It's quite a lot of floats. So if I have like a 4,000 vertex mesh, it would be like 4,000 times 4,000 over 2 minus 4,000. Which is a lot. But maybe not that bad. Because like that is kind of the worst case. So I wonder if I should just like... I wonder if I should just do that. Like just support the worst case scenario. The thing that I'm trying to figure out now is like, if this data structure, if I should like treat it as a list type of situation of like just kind of compacting it, doing it like just store this and just kind of append each additional vertex on top of it. But the problem with that is that accessing it per index... No, wait, I don't even need to store this data if I do this on the CPU. I'm way too parallel brained right now. This is... Or wait, if I still do it with a parallel for loop, the actual distance computation, that's easily done. Are there... There are native lists. But it feels weird to have a native list for every single vertex. Maybe I'll start with the naive, just linear way of doing this, and then I can worry about the parallel stuff if it's too slow. Something premature optimization, etc. You know, I'm doing nothing but premature optimizations right now. I should have just done the stupid way like weeks ago. Okay. So then it's just a brute force calculation. But at the very least, we need to store the distance in every vertex. So we do need that. And where do I store that? Let's see. I do have mesh data, but I believe mesh data is the stuff that I have to have per mesh. So the thing that I actually need, I think, is in the mesh cache, or like cached mesh data. And I think I have stuff touching that in the mesh reader. Where is my cache? I thought I had a cache in the mesh reader. Well, I definitely... Ooh, hold on. Derived properties. Yes. Okay. Okay, here we go. This is the relevant bit. Yes. Or do I actually, or I think I used this. I vaguely recall that I might have refactored this at some point. No, I do use this. Okay. So this is the cached buffer. Cool. Yeah. Actually, you know what? No, this is relatively easy to parallelize on the CPU. Yeah, actually, yeah, we can still do this parallel. We don't have to like overcomplicate it. Like if all we do is put a parallel job for every vertex, then this is going to be relatively easy. Because then the reduction is still just held by a single processor. So then the reduced minimum is just going to be computed by the same one. So then we at least get like one step better than the completely naive solution of like manually computing all of these in series. Yeah, yeah. Okay, so that's what we're going to do. We're going to make a parallel job system. We do one thing per vertex, and then each thread just collects the distances. Yeah, cool. So we are gonna need a native list of floats, and that is gonna be a cache of soft selection distance. Yeah, that's gonna be it. So then we are yeah, just the boilerplate stuff, disposing of data. Yeah. I don't know if I'm gonna need the data access function, but you know, I might as well. Okay. I don't, so this one is kind of like, I kind of brute force calculate this before I do the meshing. But I don't really need that for the soft selection. It's kind of the wrong place to put this. It should really be a like lazy evaluation type of deal. And it seems like I did have some kind of cache invalidation process here. I don't know if this is me giving up on this or if I never finished it. This looks like it's more granular. But yeah, I'll just brute force it for now. Yeah, when do it? I think it's during meshing. Yeah, this is when I bake it to a mesh. Which is kind of the wrong place to put it. Yeah, it's like super the wrong place to put it. Yeah, you know what? I think I'm gonna try to put it in the right place instead of the wrong place. I'm gonna do the the difficult thing of trying to figure out where this should go. It would be easy to put it here, but it really shouldn't be here. This is really not the place for it. Yeah. Yep. Okay. So we're gonna just steal these back. And I believe this should then, I mean, it should live in the selection system. Like when you change your selection, question is what order all of this happens in. Because this is the wrong type of selection. I think it's element selection? Geoselection, that's what I call the class. How are we feeling today? I had some headache myself. That sucks. I'm sorry. I'm feeling alright. Okay, why is this entire file white? Can I have some syntax highlighting? Or did we stop doing syntax highlighting? Hello, writer? Element.deselect all. Right. And why is it not why is it not highlighting it? I can't navigate to, or no, wait, I can. Okay. It worked there. Sure. Okay. Where is my selection changed callback? Oh yeah, there's also undo and redo. Okay, why? Wait, it works now, right? This was the file, I think. Maybe? Or is this a different one? I don't even recognize like files if one of them has syntax highlighting and the other one doesn't. Which is a whole different landscape. Okay, convert selection to vertices. I know that I do this before. Oh yeah, wait. I have something like a selection buffer, I think. And that's for the GPU selection, which is in the selection utility. But that's only for box selection. But there should be some kind of callback here. On bits changed. Okay. Okay, why is a writer so slow? Okay. Yeah. Okay. So this should trigger every time any selection is changed. Hopefully that includes when you undo. Do I actually... Writer? Hello? Writer? I know that this is supposed to exist. Why is my CPU just like spinning around trying to figure out what this enum contains? Why? Why? Why is Writer so slow? I feel like a few months ago I didn't have this problem, but now Writer is just like, I don't know, help, for like 5 seconds. Why? Okay. It's really annoying. A lot of tabs open, but why is it thinking about the other tabs? I'm not doing anything with those tabs. Okay, let's see. Is my debug stuff printing the way that I expect it to? So we had on bits changed. So if I on bits changed. Okay, yes. That is triggering. I presume it's for any element. Yes. Okay, so it marks the bounds dirty. And I believe the bounds... I feel like anytime the bounds are marked as dirty, I feel like that's also where... This is where I would also change the... Or I would mark the soft selection stuff as dirty as well, I think. Yeah. So would I use the same construct? I made a thing called dirtable. So you can like mark it as dirty, and then when you request it, it automatically recalculates it, which I believe there's even a built-in C# thing called lazy, which I think is the same same idea. I don't know why I made my own dirtable thing. But maybe it makes sense. But yeah, I think we can use that, right? Let's see, how do I define... Yeah, this is the update function. Yeah, okay. I think we can do this. So this is going to be a native list of float. And this is in element selection. Is that the right place for it? That might not actually be the right place. So I have multiple of those. I feel like it shouldn't be in here. Actually, bounds shouldn't be in here either. To do. These should be in geo selection. No? But that's okay. It doesn't have to be in the right place for now. So this would be our soft or selection distance values, or selection distances, soft selection distances, maybe? Is this Java? This is not Java, this is C#. Close enough, right? It's like, it's Java, but better. Also, thanks for the raid. Janet Akar. Hello, everybody. I am making a 3D modeling tool called Half Edge. That's what I'm working on right now. It is kind of, it's not finished. It is a little bit jank. It's missing a bunch of features that you would want from a 3D modeling tool, but it's getting there. I've got some insert edge loop tools if you want to insert edge loops. Got the usual extrude functions for fans of extrusion. I think extrusion is kind of cool and fun. But yeah, and right now I am working on a soft selection system. So basically, if you select some vertices, maybe you want to like gradually have this fall off across the mesh, so that when you move this, you also move some of the neighboring points as well, just to kind of like a terrain editor. So yeah, I'm working on that. I'm making a soft selection system. So right now I'm just kind of setting up all the data structures that I need to do all the distance computations and yeah, so that I can test it out. The right now I'm gonna do the Euclidean distance, which is kind of like the straight line distance from between every vertex in order to do the soft selection. But down the line, I'm gonna try to do a version that's based on geodesic distance. So if you sort of imagine this mesh and you select this vertex, if you have a soft selection with some given radius, maybe you don't want this vertex to actually move. If this white wireframe here is the surface of the mesh, right? Maybe you don't want this one to move. It's really close, but if it's not actually connected to this vertex, maybe you want the soft selection to kind of like wrap around this little mesh instead. But yeah, that's more advanced. So right now I'm gonna start with a Euclidean distance, so it's kind of like a spherical fall off around the center. Are we getting frame drops? Is this one still running? Okay, we don't want to run this. Okay, I can probably just close this, I believe. Okay, OBS seems to be happier now. Okay, I think we're good, right? All good? Makes sense? Way better? Okay. I don't know when things started getting choppy, but anyway, I'm implementing soft selection for my 3D modeling tool. I'm currently setting up the data structures that I need to have this distance data on a per vertex basis. Do I have a constructor here? Default value, yes, okay. We can still hear you perfectly? Okay, that's good. Okay, so this would be the native list. And then we would have the default value. Okay, so this would just be basically the constructor. So this is where we'll create the new native list. Wait, hold on. Oh, never mind. Okay. Feel like these should be static, but maybe it's fine. Okay, so initial capacity doesn't really matter. And then we want this as a persistent shenaner. And then here's where we need the actual recalculation function. So where would we put this code? This would be, this should dispatch a job. I guess, you know, I'll just put it here for now. Hear a cat in the background?
Toast! Hey! Come on, Toast! Come on! Hey, hello! Hey! Oh, no, no, no. Come on, Toast!
He could tell I was about to pick him up. I'm gonna pick him up anyway.
Hello! 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 Come on, buddy. Hey, Toast. Hey, Toast. Hello! Come on.
How you feeling, buddy? What? What? Okay. Okay, Toast. I'm sorry I'm bothering you so much. Okay. Do you plan to have double face geometry? In terms of... What do you mean by that, actually? There are many different ways of doing two-sided geometry. So which one? Oh, also, the real Zitrox? Thank you for the dono. What it gives you something for all the good tutorials. Help me and my girlfriend for shading, lerps, and all the other good content. Love you. Thank you so much. I'm glad my stuff has been useful. How are you not full of cat hair? Is the camera filtering it all out? I mean, it kind of depends on the fabric, right? Like this fabric does not absorb a lot of cat hair, but if you have like cotton is really good at like getting hair stuck, so it depends. My pants are a lot worse than this shirt. Okay. How many cats do you have? I have 4 cats. I'm supposed to have 3, but I have 4 cats. Okay, so this is just gonna be recalculate soft selection distances. Okay. Actually, how do I do the... Let's see, selected mesh data. Oh, that's not what I wanted. I wanted the... Or no, wait, this one probably branches. Okay, right. I was trying to think of like, because right now your selection could be something that's not vertices. Like if you select faces, Yeah, like I kind of want soft selection to. I mean, actually, this really depends on how like pedantic I want to be. Do I want to convert all of my selection into vertices and then get the vertex distances, or do I actually want to do like vertex to edge and vertex to face distances? If your mesh is really low poly and you have a very like, if you have a lot of very like skinny triangles, it might be good to actually do the full distance test, but just checking vertices is probably a good approximation for most cases. Hmm. I think we could just do something like only doing this if we're in vertex selection mode. Oh wait, it has to return the. Oh, because I'm assigning to. Oh, I mean, sure. It's a bit recursive, but that's okay. Do you look at your keyboard when you type? No, but I really need my keyboard to be within my field of view, I've noticed. Like whenever a cat is standing in the way so that my keyboard is not within my field of view, I do so many typos, which is weird. Yeah, I don't know. I think I just need it in my field of view just so I can like get a sense of where my hands are. I don't know. I don't know if it's because I recently switched keyboard and keyboard layout, or if it's because I sometimes have my keyboard on top of my tablet, sometimes it's in front of my tablet, sometimes it's ahead of my tablet. Like, I don't know. But yeah, I really do need to see my keyboard. For some reason. Learn more from you than the professors at our university in Germany. Oh, hell yeah. Or maybe that's not good, actually. I feel like you should be learning more from your professors. Keyboard layout? Yeah, I switched from the Swedish keyboard layout to the US keyboard layout. And also switched keyboard to a different one. So at the same time, so now I've had a pretty long adjustment period. It took a long time for me to get used to it. Okay, so this should be a job system situation. Let's see. So what do we do here? We want to I guess first we can set the, or actually can you, oh, it's capacity, not set values. How do I reallocate? Oh, resize uninitialized. That's probably what I want. Or just resize. Is uninitialized, it's going to resize without initializing the memory? I'm guessing that's what it is. Actually, we should first check if this element type is not vertices, then we just return. Well, I guess return this. Okay. Vertex count. That would just be count, I suppose. Does this dynamically count? Does this, okay, count selected. That's not exactly what I wanted. But that I will be needing something like that at some point. Okay, but I want the oh god, I forget how I access the mesh data. Because this is mostly selection data. I'm gonna brute force it. Current scene. It's gotta be, no, I've gotta have a mesh. There's gotta be a field to access the mesh here, right? Or maybe I don't? Actually, I think I make an assumption about stuff here. Current selection is elements, but selection manager.mesh is the current. Okay, so this is the shortcut. Okay. Okay. Mesh dot vertices dot length. And then we want to set up a job. I don't remember exactly how I set up all of the job stuff. I can probably just look at one of my previous jobs and kind of mimic the whole thing. Right, I had this whole mesh reader thing. Okay. Okay. You know what? I'm just gonna copy all of this, create another one underneath. And then this is a job for soft selection distance. It's not really part of the cache, so. Okay, we do want a mesh reader. We don't need an angular threshold. Maybe we want a bool later for if it's Euclidean or not. But that's for later. Actually, maybe I want to... Writer, hello? I've commented this line 3 times. Hello? What? Thank you? I don't know. Why does that happen? Godot port when? Well, this modeling tool is not a Unity plugin, by the way. So you could use it for Godot. If you do want to make 3D models for Godot, you could use it for any engine. All right, so what do we need access to? I think we just need access to the vertex positions, right? That's pretty much it. Which I believe we might be getting through the mesh reader, if I remember correctly. Yes, because we get access to the data there. Do I really not need to like let it know about the fields in the mesh reader? Maybe I don't. Just found out you made the beauty of Bezier curves. That video made me fall in love with Bezier curves. Thank you. It was a similar thing for like someone made these animations on Wikipedia for the de Castelliau animation for the construction of the Bezier curve. To me, that was my moment. Like the moment I saw those GIFs on Wikipedia, I was like, Hell yeah. Look at that. Look at it go. We got these like discrete sets of lines, and then somehow you get this like really, really nice curve out of it. I love that. It's super cool. That was my moment where I fell in love with Bezier curves. And then I started not liking Bezier curves once I got into other splines, but they still have a special place in my heart, you know? Oh wait, we do need the output, actually. So the output is a float. Soft select distances. Wait. I started modifying the wrong one, I think. Hold on. Hold on. I've been doing cross modification. You know what? It'll be fine. Okay, this is the one that's supposed to be the that one. It's okay. I'll just revert the file in version control after this, because this is going to move out to a separate file. You know what? I should just do that now. Okay, so native array of float. This should be soft select distances. Guess that should just be the input. Let's just put the Euclidean thing in here. Favorite spline. There's so many, and they're like they're good for different reasons. I mean, I do have a soft spot for the B-spline. Like the cubic B-spline is very, very pretty. And it achieves like the fact that it achieves like C2 continuity. Is really, really nice. It's a bit of a shame that you can't like it's not easy to do like interpolating stuff with it, but I think it's really nice. I think the moment you get to the more like flexible advanced ones, like I don't know, when you start generalizing into like NURBS, they become so much less clean and they're a lot messier to implement, and they're like computationally just a lot. And so and all the stuff like how it deals with knot multiplicity is kind of gross, and I don't know. It's weird. It feels a bit like it feels like a hack. But I can see why they'd be useful. So I don't know. I think the cubic B-spline is very, very cute. Okay, let's see. Execute. Okay, so this is where everything happens. So we don't super need any of this. So that's going to be our distance. And this is going to be executed per vertex. We're using the heat transfer function to compute soft selection. It's like applying weights proportional to the distance to the selected mesh onto the unselected mesh. It's specifically there is a paper. Heat method for geodesics. Here you go. But right now, I'm just doing Euclidean distance. So just to set up everything that I'm doing right now. Because the heap method stuff is much more complicated than the Euclidean distance. So now I'm kind of just setting up the structure around the whole thing so that I can actually use it within my 3D modeling tool. Yeah. Actually, this would be the minimum distance. Okay. So then I need to enumerate my selection, which might be a little bit hairy. I don't... I'm not entirely sure how easy that is, or like if I can do that through a job, but I will try. Because jobs have some restrictions on what you're allowed to do. But yeah, I'm gonna try passing the selection bits into it, and then we'll see what happens. You're making your own modeling software? Yes. Can you get C infinity splines in principle? Yes, it is. C infinity splines is not even that hard to construct. But the problem is that the spline will generally look garbage. So there's like there's a tendency for like, because I was looking into this a long time ago when I was doing the spline video. Like you can make a C infinity spline relatively trivially. Like all you need to do really is to find a sigmoid function like this, right? That goes from 0 to 1, and then with assuming a flat start and flat end, and then ensuring that you have C infinity at both of these points, like here and here. I don't know how to draw infinity without drawing an 8. So if you have this, wait, I should write. I think this was supposed to be a 1 and not a marker. Okay, 1. There we go. If you have this function, then you can just use this as your, or actually, there's one more step. Because you need to find another one that's like this. And then both of these need to sum up to 1, right? So each basis function, all of these should sum up to 1 for every value of t between these. Once you have that, you have a C infinity spline. But like if you do use this for a spline, it's gonna like if you create a few control points, and you want to do a spline like between these points, it's not gonna look smooth. Like you kind of want it to have some kind of smooth interpolation like this. It's gonna look something like this, where you get like very large like flat spots, and kind of in like relatively unpredictable places as well. I don't know. Usually you get these like weird like kinks everywhere, and you get like really weird behavior when it comes to that. There's also I also don't know, the parameterization might also have issues where like it might move very slowly near control point, so it might be very slow and then it zoops over and then it's really slow near this control point, and so forth. And so like if you just want a C infinity spline, like that's not the hard part. The hard part is you want a C infinity spline that is interpolating and that has a nice shape. And like that nice shape part is like really important. And yeah, so yeah, you can totally have C infinity splines. I've constructed one before. It's just not very useful. And then also you usually want to have a usually you also want to support non-uniform splines. And that makes it significantly more complicated. I didn't really get into non-uniform splines in my spline video, but non-uniform splines is kind of like when you kind of unlock the true power of splines when it comes to animation. For geometry, it doesn't super matter, but for animation, it's really important. I think I missed a bunch of comments. Feel free to ask something again, by the way, if I missed your question. Norwegian Game Dev here. Hello. Ben makes no sense. I will sadly miss Spillconvented. That's a conference I'm going to soon. I asked and they said they'll be recording your presentation on your behalf. Will you be posting it somewhere I could then see? Yes, I'm going to be posting it on my YouTube channel. I hope we agreed to that. I think we did. But they were very like, when I was talking to them, they were saying that like, oh, I'm not sure if we're gonna record, but maybe we can set it up and I'll talk to our like AV people and maybe we can work it out. And so it seems like it was kind of off the cuff. Maybe I should explicitly ask. I usually ask if I can put it on my YouTube channel. Because it's good to get that sorted out like ahead of time. But yes, it'll probably go on my YouTube channel. I don't think they would like protest. I'm also going to be bringing my own camera, so even if there's some kind of shenanigan where they don't want me to use their official footage, I can maybe use my own footage instead. I don't know. So yes, it'll be recorded. How big of a decision was it to paint the walls red, or did the room come like that? I painted it myself. I just wanted something nice. Honestly, I wanted a nice background for my stream, and I think that would make for a nice color. And yeah, I like it. I think it's nice. It's all red. It's a little dark in here now, though. Hold on. I think when I have the ISO set to auto, I feel like it's not doing the metering the way that I would want it to. What's the best spline for getting distance on it instead of 0 to 1? So arc length parameterized splines are relatively rare. I think that I only know really of 2 splines that are arc length parameterized, but they're not super useful. So let me switch scene. Did you paint it to match the mic? No, I don't know why. I just really liked red hardware, and then I have a lot of red audio things. But yeah, my wall is it's actually I took the red from Team Fortress 2, like the Team Fortress 2 team color red, and then I just converted it to IRL colors. So it says Team Fortress Team Red. So if you want a spline that is moving at a speed of like 1 meter per second, That's an arc length parameterized spline. Most splines are not arc length parameterized. So if you make a Bezier curve, like something like this, then the speed will be much faster in the beginning, and then it'll kind of scrunch up in the middle, and then it'll speed up near the end. So you can see that if this represents like equal parameter spacing, like you increase the u or t, the parameter value, by the same amount for each of these steps, it moves way slower here, right? It like in some cases that's actually useful if you're doing geometry. You kind of get this automatic like higher detail where there's more curvature, which is kind of useful, right? But for animation, you usually, though not always, no, in some cases, you do want to treat the spline as a purely geometric thing, and then you have something moving along that spline that has its own speed and its own like independent motion. So an example of this would be like a roller coaster. Like a roller coaster, if the roller coaster track is defined by a spline, then the quote unquote speed of the spline should never be taken into account for like a roller coaster cart that's moving along this shape, right? So for that, you usually want an arc length parameterized spline. But most splines are not arc length parameterized. I know of 3 arc length parameterized splines, one of which is my own. So the most common one is the linear spline. If you have a bunch of control points, you have linear segments between them. This is trivially easy to arc length parameterize. And this is probably the most common one as well, because you can always convert any spline into a linear spline. You can just like if you make it detailed enough, you know, it'll kind of look smooth, right? So this is probably like, and this is what I do in my videos when I draw curves in my video, when I draw a spline in my video. Like this is the way that I like discretize all of my splines. So yeah, so that's the most common spline that's arc length parameterized, or can be arc length parameterized trivially. Then there's another spline known as a bi-arc spline, which is a little bit of a weirdo. Oh god, I don't have good intuitions for bi-arcs, but basically bi-arcs go off of the concept that they're made off of circular segments. So you can sort of imagine circular arcs that kind of interconnect. I don't even know what this one would be like. Probably large radius circles here. And then this would connect to something or other over here, or whatever. Something like that. So this would be a bi-arc spline. This one is also trivially easy to arc length parameterize because, you know, circles are very easy to do that with. That's no problem at all. Yeah. But of course, bi-arcs have a very, very particular shape, and I don't actually know of a good use case for bi-arcs. Like they feel like a mathematical curiosity more than anything else. But I guess one big advantage that bi-arc splines also have, now that I think of it, is that actually that applies to the linear spline as well. But it's one of the splines that is easier to invert than other splines. And by inversion, I mean instead of, you know, given a parameter value, find the point in the spline. That's relatively easy. But the inverse is given a point, find the parameter value, which is much harder. This is a root solving search, and doing this is a lot easier for both linear splines and biarc splines because there's an analytic way to just project that onto whatever segments you have. Yeah, for both the linear segments and the biarc spline. This gets a lot more complicated if it's a Bezier curve, because now you need to try to root solve the like distance function along the whole spline and yada yada. Biarcs are probably good for modeling certain roads, taking traveling speed into account. Not really. There are better splines for that. Like usually for roads, they use I think it's called like a track transfer curve, which is based on the Euler spiral. And the Euler spiral is the curve that has constant curvature. And that is usually used for things like railroads and roads and that kind of stuff. Yeah. Anyway, so this linear splines, that's the first one I know of. Second one is biarcs. And then there's a third one, which is it's a spline that I have in my unreleased spline plugin that I should really release. It's just been sitting on the shelf for a long time. I have a spline it's just called a rounded polyline, where you define a set of points, and every point has I forget if I parameterize it as a radius or how I set it up, but basically if you imagine the hole like this, it basically has 3 different parts to it. So you have linear segments, and then there is an Euler spiral segment that then goes into an actual circular arc, and then an Euler spiral segment that goes into, oh my god, this is the most awkward angle, that then goes into another linear segment. Yeah, and then this, I think I parameterized it by this distance right here. I forget. I think I did. Because then you don't get weird behavior if it's a straight line. But if you define it by radius, you do get weird behavior with a straight line. I think. I forget. Or maybe I did like curvature or something. I don't remember. But yeah, so this spline is also arc length parameterized. The arc length function for circular arcs is trivial, straight lines is trivial. I think the Euler spiral is also analytical, if I don't misremember that. I think it is, but I could be wrong. But I think it's arc length parameterizable. So yeah, so this thing that I just call it the rounded polyline spline because I didn't have a good name for it. And also because that's kind of what it feels like to use it. You're kind of like placing control points and then rounding the corners, sort of. But yeah, so these would be the arc length parameterized splines that I remember right now. Oh yeah, and this one is C2 continuous, whereas this one is C1, and this one is C0. Are you building a 3D modeling tool or what? Yes, I am. Right now I got on a tangent to talk about splines. Is there an interpolative spline that has a continuous second derivative? Kaplan-Mauer splines from my understanding don't have second derivative. No, they do. There are higher degree Kaplan-Mauer splines. You just need to use the I'm not sure if it would be the quintic or if it would be the hexic Kaplan-Mauer. But usually pretty much everybody just uses the cubic ones, but I think the higher degree Kaplan-Mauer would give you C2 continuity. Okay. What was I even doing? Oh, I was also going to say that, like, even though most splines are not arc length parameterized, like, in many, many practical use cases, you tend to discretize it into a linear spline anyway. And that kind of lets you use whatever spline you want, and then you discretize it, and then this is arc length parameterizable just fine, right? So in practice, it like finding, like trying to find arc length parameterizable stuff is kind of more of a mathematical curiosity, and in practice, you mostly just discretize everything into linear splines anyway. Or you can discretize it into circular arcs. That's also an option. What? USB sounds? Hello? What? Okay. All right. I don't know who did that, but I can use my mouse. I can use my keyboard. Okay. All right. Where was I? I was... Right. I was going to make the... Yeah. Okay. It was you, keeper codes? You... Okay. Please don't futz around with my USB devices while I'm streaming. So you need splines to be easy enough for computation, stable enough. So moving one control flow doesn't move the entire spline. Yes, and maybe something else I missed. Well, yeah. I mean, those are usually the things that you care about, but it depends on your use case. Because sometimes you want some features, sometimes you don't want some features. Like arc length parameterization is generally not something that you want if you're doing animations over time, right? Because then you want non-uniform splines where you have a lot of control over shape, but then you do want that time dimension as well. Yeah, but then for certain other cases, if it's like you want to interpolate some path and you like just want some kind of smoothing feature, then you probably care a lot more about continuity, and you want to be able to have kind of sparse data, and you probably want to like you probably want to make it, just make it as smooth as possible, you know? Did you ever explore algorithms that discretize splines based on curvature to create more points at high curvatures? I looked into it for a bit, but honestly, I found it to be like I honestly found it to be not that useful, and I found that the point spacing you get with Bezier curves more often than not was pretty much like good enough for my use case. And so I feel like I didn't really have to do that whole like root solving thing for like splitting it up based on curvature. So yeah, I don't know. I tried it once and I just didn't really go back to it because it felt like it was just unnecessary. And like the computational cost of doing that in many cases is just more than just splitting it up a few times more, and then you get like a good result, at least in my use cases. So yeah, the kind of like stupid solution is often good enough, predictable enough, fast enough. Is rigging supported in your software? No, rigging is not something that I have support for right now. And it's probably not something I'm going to have for like version 1.0 either. So that's probably gonna have to wait. I think like there's kind of a whole can of worms for doing rigging and especially animation. Yeah, like rigging and skinning and like painting weights and all of that stuff is kind of a whole thing. So that's something that I'm kind of saving for like a future update. Otherwise, I feel like I'm gonna get stuck in rabbit holes and never finish this if I like try to implement everything, you know? Anyway, for each, can I use selection bits dot oh, yeah, like that. Okay. Okay, so we need this vertex location. So then that would be mesh reader dot vertex ID. Wait, is that dot position? Is a software? Wait, are you asking if there are software that works for any different XYZ order? Or are you asking if I'm going to support that in half edge? I know that Maya, maybe 3D Max, allows you to select either Z or Y up, but you can't switch the handedness on those. Okay, so let's see. We got this vertex location, and then we're going to iterate through the other vertex IDs in our selection. And this is the line that I'm not sure is going to compile, but we'll see. So if no, we don't need if statements here. We just need the actual I guess we're gonna do square distance at first because that's gonna be much faster. Yeah, so we are gonna do let's call it V. So we got that, and then add other vertex ID position, and then minimum distance equal math dot minimum of minimum. Wait, this should not be 0. And math dot between P. No, wait. There we go. Okay. I thought we were making one. Yes. I mean, I am making a 3D modeling tool, and I do have plans to make it support any axis configuration. Animation, I'm not going to add animation for 1.0. 1.0 is going to be focused on modeling. Rigging is a little bit easier, or actually, it depends on what you mean by rigging. If you mean setting up like custom controls for rigs with like IK and like look at targeting, like all of that stuff, definitely not for 1.0. Maybe like very, very basic like weight painting and joints and setting up a hierarchy for that, maybe, but probably not. I think, yeah. But like the basics of rigging is a lot easier than animation. Animation opens up a huge can of worms. So that I don't want to do for 1.0. Okay, I think this is it. Right? We just iterate through the selection. Or no, wait, hold on. I got this backwards in my mind, but it might still be correct. Yes, because this is the vertex we want to know the distance to. And then we go through the selected vertex. And then we get the square distance, and then we want the minimum of that. Yes, okay. This is correct. That's fine. The big question is... Yeah, okay, this was what I was afraid of. I was pretty sure this would not be supported. Okay, I'm not going to be able to use selection bits like this. How do I do this then? Basically I need... Do I have a nice way to extract the indices? Actually, how do I do the enumeration? I just... Kunk? Sounds like a slur of some sort. Wait, hold on, what is data? Wait, I already have a... Or no. Or wait, this is enumerating the chunks, but not the... Right. Okay. Yes. Okay, how do I break this out into a nice format that burst jobs will accept? Because I'm guessing any kind of enumeration is not supported. Toast? Hello? So it would feel kind of gross to copy paste this code. Returns are enumerable. You can just for each in bits.enumerate. No, that's the thing I cannot do. Because this is a burst compiled parallel job, and I cannot use this type in there. Or are you saying that like if I just pass the like the bits themselves or something? I mean, maybe I can just do some kind of abstraction. But then, no, it would still have to be a value type. Or like, actually, like if I have a native array, can I, like, I have to be able to do a for each over a native array, right? Like this should be allowed in a job. But can I do stuff like select here? Or does that... No. That does not work. Okay, because the intermediate types are not burstable, I guess. What are your best tips on coding regarding architecture? Do you use dry, kiss, etc.? No clue. I don't know. There's not like a specific thing that I follow. So I don't know. Very useful advice. Okay, so how would I want to do this? I guess I don't use Unity. I'm writing modern.net. It is strange for me that this type doesn't have its own enumerator and using coroutines. It's not that strange in this, because this is kind of a special case. Like usually you don't have to do this shenanigans. The only reason this gets complicated is because I'm putting it in a multi-threaded context. Copy the indices into a native array first. Oh yeah, I guess I could do that. But then... it's a little bit spooky. But not that spooky, actually. No, that's fine. That should be fine. Yeah, okay. Let's just do that for now. Which means we're gonna have a read-only native array of int, and that's gonna be our selected vertices. Okay. Okay, which means we don't need the selection bits anymore. So then we would go through selected vertices instead, and then that should all work. But now we have to pass the... why is this not public? I feel like it should be public. Okay, so now we need to pass the selected vertices as a native array here. Can I make it a native list? Actually, I could, but then I could still just pass it as a native array, so that's fine. Okay, so I'm not really calling this anywhere, but I am... Let's see, I was supposed to call it from here. Okay. And let's see, how did I usually set this up? Let's see, job handle, and then you call schedule. Okay, and this returns a job handle. So that's got a bunch of dependencies, and then you call complete on the job handle. Okay. Gotcha. So we need to have some kind of job handle situation. And then make our soft selection distance job. We want a mesh reader. And then, okay. Then we need the, hold on, this would be the vertex count. Ooh, this, I don't know about the inner loop batch stuff. I feel like this should be pretty low. Or I think it should be high if you have a low amount of selection. But if you're selecting half of the mesh, I think this should be, or no, the other way around. It should be high if you have a small number of things selected, but it should be low if you have a large number of things selected. Let's optimize it for worst case, I think. Okay, so we got the mesh reader, and then what next? Euclidean. True, I don't even use that parameter. Soft select distances. That is this thing. You know what? It's a little bit silly to type that whole thing out every time. Okay. Right, we want to make sure that this one is of the correct size. So that is going to be, right, that's based on the vertex count, which I should paste there. Native array options, clear memory, uninitialized memory. We are going to overwrite the whole thing, so might as well do uninitialized. Okay, and then we need to create, what do we need to create? We need to create the, right, the list of selected vertices. Okay. And that's going to be, or you know what? Just create it right here. Let's just do it. It can just be a native, no, yeah, native list actually. And then this would be selected verts, and it's a native list of integers. They're indices. Okay, capacity would be count. I don't know if count, do I actually enumerate through this one? Calculate count. This sounds like an enumeration. Oh yeah, but it's using pop count, so that's actually not too bad. That's fine. That's okay. It can be a native array then. Allocator temp job? Maybe? I forget which one to use. Wait. I kind of need the index. I would like an index. I kind of like the Python had a thing where you could just add another int parameter to get the index and a for each. I think that was kind of cute. You can sort of set it up in a similar way with like, you can make like extension methods with tuples that do that. I've done that in a few cases, but it's a little bit clunky. Temp job, as long as you can guarantee, takes less than 4 frames. I mean, it's synchronous right now, so can I just use temp then, even though it's in a job? Because it should be synchronous. But I guess if it's asynchronous, then usually you would use temp job then, if it's multiple frames. All right. What am I doing? Oh, this is setting up the list of selected vertices. And then we need to actually execute the parallel job. So we need to pass the selected verts in here. Yeah. Why is it sad? Oh, it's missing the soft distance thing. Oh wait, and it needs to be an array. Okay. I guess... should it really be a native list here? Because I think... Because I don't want to have to reallocate it. It'd be nice to do that automatically, but... it would be really handy if it had the correct size. Maybe resize. Okay, does resize. It has to actually populate it, right? When I call resize. Like, I'm guessing it doesn't just set capacity, because that would be sad. That would be sad times. Sets the length of this list, increasing the capacity if necessary. Well, that was perfectly ambiguous. Go to definition. List data, resize. It looks like it does set length and not just capacity, so I think that's all right. I think we're good. Hopefully. Okay, so is that it? Do we just call complete? We don't really need to have a we don't really need to have a whole situation here. We can just complete it immediately. And then I guess we can dispose of the native array. Okay, I don't know. Theoretically, this should work. This seems fine. Okay. Neat. So now we should have that data. But we're not doing anything with it. We just calculate it, and then it's going to sit in memory. But I guess I should run it just to make sure that we're not crashing. Well, seems fine. I don't know why this is printing every single frame. That's a little bit concerning. You can't pass temp allocations from the main thread into a job. Typically you use temp for allocations inside of a job itself. Oh, okay. Well, if so, I should probably swap it out. It didn't seem to explode though, so I believe that works. So who knows? Probably. Maybe. So, the next thing then, where's our list? I made a to-do list. Compute and store the selection distance field. I believe we've done that. We just can't look at it. So now we need to visualize it. Okay. I wonder if I should have used my... Like instead of using native list, I feel like I should be using my because native list is in CPU memory, but I do have a data type for a buffer that's supposed to live both CPU side and GPU side. Where is that? That is this thing, dynamic G buffer. Yes. So I believe I want to use that. Instead of a native list. Okay. Kind of forgotten exactly how how I set up the dynamic G buffer. It was a while ago I touched this. But I think it should be fine. Okay, what is the constructor here? Name and stride. Okay. Name. Did I have a naming convention for these? Probably, because these are shader properties. So... yeah. Selection, perfect. So this is going to be a G buffer for the soft selection. Soft selection distance values. soft select dists. Dists. Okay. Wow. I already forgot the name of that file. What was that file? Too many tabs open. I'll just close things until I see something that shader props. Okay, shader props dot that. And then stride, which would be size of float. Okay, this is just going to be returning itself. So that doesn't change much. Okay. Okay. So then, I have a length and a count, but I also have a set length. I think that's what I want to do. Set length v count. So I believe this is lazily, yeah, it's lazily dealing with the GPU data, but the CPU data is set explicitly. Okay, cool. That's perfect. So then, let's see, we got the selected vertices. We don't need that on the GPU, so that can remain the same. And then here, it's just going to be dot data as array. Also, I have not been reading chat much. Sorry if I've been missing questions. Okay. Seems like no questions, I think. Or just stuff that's too old. It's past. The moment is gone. All right. So, mesh reader, we're passing that into the job. We are passing in the soft distances, doing all of that. And then after this is done, we need to upload it to the GPU. So then we do soft distances dot upload, maybe? Is soft distances not what I think it is? No, it's there. Okay. I thought I had a force like a upload or sync. Oh, download, upload, download. Well, this is in the opposite direction. Oh, actually, maybe I did that. Maybe I do that lazily, actually. Yeah, okay. Ensure GPU buffer is ready is what I wanted to call. Okay, so this uploads it to the GPU, I believe. Yes. I don't think I technically have to call this, but it doesn't hurt, I think. Okay, do I use global parameters for this? It does not look like I do. So I believe that's what the assign to. Either property block or a compute shader. Do I not have a global parameter for that? I guess I just use compute shaders for it. I feel like I would use global ones though for like for the mesh data. Even like the selection buffers. Where do I this one is global. I don't even see mesh data in here. Mesh data, hello? Oh, I have the geodata buffer. Oh yeah, I remember that. Okay. Okay. Right, which is a separate category. Right. But serializable? Yeah, it's if you want to turn it into serial. Does G buffer stand for GeoBuffer? No, it's graphics buffer. So G buffer basically just means, or graphics buffer is basically just a block of memory on the GPU. And so a lot of this code is like dealing with passing data to and from the GPU, which is a bit of a mess, especially downloading from the GPU is a little bit spicy because it can sometimes stall. And generally that's not something you want. But uploading to the GPU is very, very fast. Okay, I don't think I need to care much about these, but I am still wondering, like, where... Yeah, maybe it just is... I just set it through the compute shader. Maybe that's it. I just thought... I just thought I had some place where I was like, oh, set global variable here, but maybe I just don't. Okay. Well, we can just go to the actual the rendering. Render drawer. Geo drawer. This seems relevant. Drawer vertices. This is what I want. So we got the command buffer. Draw all elements, and it's drawing vertices. And then draw procedural quads. And I'm guessing it's just... Hold on, it sends pass into it, and that's an integer. Oh, it's just a rendering. It's picking the pass in the shader. Okay. That makes sense. The thing that I want to do now is that I want to make the vertices of your selection should be the soft selection fall off. That's what I'm doing right now. So I need to somehow pass this soft selection information to the shader, which should just be a matter of setting a buffer like this. Actually, I think this is exactly where it should go. Yeah. I guess I would also need to know if we are in soft selection. So, where would I get this? So this would be, is it even public? Oh wait, I do. What? How do I reopen close tab? There we go. Let's see. That's the job, which we are calling from. We're executing that here. We got our soft select distances, which is here. This is the thing we want, which is an element selection, and it is public. Okay. I already forgot what it was called because I am bad at this. Soft selection distances. Soft? Okay, element selection is the wrong type. Current selection. Soft selection distances. Oh, you know what? It's gonna be dot peak dot assign to, and then the material property block. It's a bit of a reversed situation here, but that's okay. Okay, so we assign that to the property block, and then I believe that should give us access, but we also need the state of whether or not we are actually in soft selection mode. Which means we probably need another name here. So is soft, or is in soft select mode. Okay. Okay, and to check that, we need to access one of these, I guess. Do we access that in here? Yeah. Okay, it's a global state. Sure. We can do that. Use soft selection. Okay. How does differential geometry apply in the soft selection stuff? I linked a paper in the description that that basically uses the heat method to get geodesic distance. So yeah, look at that paper and you'll find out. Okay, I super need to go to the bathroom, but I feel like I just went to the bathroom, so it feels silly to go to the bathroom, but it's almost the code red. Uh, so I will be right back. Okay. Let me just put something visually interesting on screen. Look at that. Look at this torus. Don't we all like a good torus? Look at that torus. Neat. Wow. I'm gonna be making some tea. Oh, it's actually kind of late. How long have we been streaming for? 4 hours. Okay. I feel like we're close to having the Euclidean version up and running. So I think we're close. We're close to having the basic version here. So theoretically, every distance value should be calculated at this point. They should actually be happening the moment we make selections right now. We're just not visualizing that data at all. She reminds me of a childless feminist. I actually have 4 cats, so don't call me childless, okay? That's an insult to my 3 boys and my girl. Okay, I think my kettle is ready. That software looks nice. Thank you. I need my tea mug. Um, oh, this person is still going. React enjoyer. It's over. Lil says you can make 3D ovals, but you will never wake up to a smiling baby and a happy family. It's not hatred. She knows it's true. These little feminist yuppies in the tech scene pretending they're happy making 3D ovals. You're the problem, not me. I will take my ban with pride. Silence me, I welcome it. Yeah, okay. I really hope React Enjoyer finds some enjoyment in life beyond React, because it doesn't seem like React is doing too well for this person. Okay. You say all this, but I bet you won't invite me to a Discord call. I would absolutely make you cry. Why would I want to talk to you? There's no reason. Where was I? Oh yeah, I was gonna upload this to the GPU. Okay, so this should be passed in properly. Automod caught the next message. Enjoy your soulless existence, making 3D circles, dumb retard. I'll see you when you're 40 and childless, asking where all the good men have gone. Okay. Yeah. I just don't know. I don't know, like, I don't know how these people don't see the irony in, like, I don't know, like, I'm not the one joining random stream chats to yell about, like, yell into the clouds. So, oh my god. Anyway. I should probably ban them, at least, just to clean up the chat a little bit. Let's see. Okay, there we go. Don't let them get to you? No, I'm mostly concerned for their well-being because they seem to not do very well, to be honest. Okay. Remind me in a few seconds. 30 seconds? A minute or something? I don't know. How long does tea take to make? I don't know about this particular tea. Let's give it 2 minutes. Remind me to go get my tea. I'm actually kind of cold. Okay, so prepare to draw. We are passing the soft selection distances. Do I maybe want to put some kind of guard here? Probably. Although it should not be based on box selection. It should be based on... Or no, wait. We're setting that globally. We don't need to set that here. I've already set that. So that is done, but I do still need to check here. which was in... I probably closed the tab. No, not that one. Oh no, it's over. I forgot. Okay, reopen, close tab. Let's just... There's no shortcut assigned to this. There we go. This is what I wanted. So viewport, right, should be like viewport.state or something like that. Do I have a viewport here? Viewport? State widget? Oh, it's in the scene. That makes sense. Okay, yes. Okay, so current scene dot viewport state dot use soft selection. Okay. T event reminder. Thank you. Or no, wait. It should be not off. There we go. What's the tea? Most of my tea is usually some kind of fruity black tea. But this one is the... I don't even know what it's called in English. It's specifically like a tea brew from not Gothenburg. Gotland, the island. In Swedish, it's called Guteblanding. So whatever that is, but it's a very good tea. I believe it's kind of like it's like black tea. It's got some hints of licorice, but it's also fruity at the same time. I don't know. It's really good. Can you spell it? There you go. That's probably too warm. I want it now, though. Oh, I have condensation on my glasses now. Go away. Go away. Thanks. What are the songs you used in your splines video? Those were made by Jazz Mickle. So you'll have to ask her. There's been quite a lot of people who have asked about those songs. And yeah, I did say that it's totally fine for her to like upload them and everything. I just don't think she's done that. Yeah, so you'll have to ask her. But they were custom made for the videos, so they were not existing songs. Is Gute blending expensive? I would imagine that for most people, shipping is going to be the expensive part, not the actual tea. It's just tea, right? Unless you're like actually in Sweden. Okay. So theoretically, we should have access to both whether or not soft selection is enabled and the distance values. So all we need to do now is to update the shader for the vertices. So each vertex here, the little dots, that's all drawn using a shader. And now what I want to do is that I want these dots to show the soft selection gradient. So let's see. Render vertices. Okay, let's see. We got the selection states. Ooh, this is gonna get a little bit hairy if I want to make it, if I want to like pipe into my selection state system. Well, that's probably okay. We can probably just like slap some hackiness on top of this. Okay, now we just need to remember what all of my properties are called. So that would be in shader properties. So we've got is in soft select mode. Is there, okay, do I have this? I do. Okay, so I'm just gonna add that here. Okay, and just to double check. I am doing set global int here. Oh yeah, not global integer, because int is the legacy one, which does set a float. So I believe it's correct to have that be a float. Wherever that was. Nobody knows. It's been lost to time. Okay, but I do need the okay, so that's the state, and then I need the name of the distance buffer, which is hopefully just this. Okay, how do I use this? Right, read-write structured buffer. So I would do a similar thing, but with this, and just read. Okay, that would maybe be in selection buffer. No? Okay. Selection drawing, maybe? Vertex utils? Editor state? That's where... Okay, that's where the globals are. Hold on. Okay, I just feel like it doesn't belong in here. Oh wait, it is an editor state. Yeah, although I kind of only need it for the vertices for now anyway. Okay. So this would be the vertex. Color is set here. Okay. I'm just going to override the color for now. When using soft selection. So if we're in soft select mode, I'm just going to set the color to black for now. Just to make sure that we're editing the right shader and everything. Have you ever worked with fixed point types? Yes, I kind of did by accident. I was like, oh wait, I'm writing a fixed point type now, aren't I? But not that much though. All caps from Bedro. Oh my god, are you the you cannot multiply the vectors person? Yes. That's an interesting legacy to have to be the one to question whether you can multiply vectors, but yes, I did a talk about multiplying vectors. Okay, this works. Look at that. Okay, so we know that the soft select mode works. So now the big question is, do we actually have correct distances? How would I do this? Okay, I do want to use the color. Let's see here. Selected color. And we need the distance from selection, which is going to be soft select distances of our instance ID. If you want to multiply vectors, you should do tensor algebra or geometric algebra. Well, I'll have you know that the talk that I titled Why Can't You Multiply Vectors is a secret talk about geometric algebra. So that is exactly what that is. Okay, so this gives us the distance, but we don't want to color it by distance. We want to color it by inverse distance over some particular distance, I guess. I don't actually know how big. I don't know how big anything is here, because I don't have any. I don't know the grid size, so I don't know what distance is 1. But if this is a distance of 1, or wait, actually, hold on. Okay, this is a distance of 1. So we want to set this to something like fall off of 5 or something to test. Okay, so the selection weight is then going to be distance over fall off distance, but we don't want it to be negative, so we clamp it to ensure we don't have any negative values. And that should be it. So then we set the color to, do I have color here? Color element selected dot RGB or something. Wait, what is this? This is a float for. Okay. Multiplied by selection weight. Okay, writer had a bit of a hiccup there. Oh wait, this is not enough. We need to do 1 minus all of this. Or no, hold on. And change it to a minimum of 1. Yes. I think. This got more complicated. I'm just gonna do the inversion in here. This makes more sense to me. Yeah. So this is just a linear fall off for now. It's gonna be some other shape down the line, probably some kind of Gaussian fall off. Or just the standard cubic S-curve. Okay. Okay. Is that it? Is that gonna do? The soft selection is using the distance along the actual 2D surface, not distance in 3D space. This is a long story, but right now it is using Euclidean distance, but the goal is to, in the end, use geodesic distance, yes. But right now it's just Euclidean distance. Okay, well this doesn't work. It looks like it's basically getting values of 1 everywhere. Okay, so let's first just overwrite this with the distance. Just for debugging. Okay. So right now it looks like everything is 0. That would be sad. Let's do let's put a little frac on that just to see if we have values that vary, which it looks like we do not. Okay, this suggests to me that we are not getting any values in here. Okay, why is that? So are we setting the soft select distance? No, we're setting that in the property block. Should we, though? Should be fine. I even used the assign to stuff here. Euclidean distance is the distance across a 3D regardless of the surface. Yes. Huh. Hold on. Are we not calling this? That's a little concerning. Are we not even entering here? That would be weird. Okay, I am calling this with true somewhere, right? Wait, what is currently in scene tool? Oh, or hold on. Oh wait, if it's false. Oh, that makes sense. Oh my god, I just had that backwards in my mind. But then this should be true. I guess 2 points could be very close in Euclidean but very far on the surface. Yes, exactly. That would be the point of using geodesic distance. Okay, include selection state is printing. Okay. Oh wait, okay, so now it is setting the soft selection buffer. What does it contain though? We're gonna just print it. Huh? Oh my god, everything's detached. Oh wait, I can remove this. Can I go back to Unity, or is Unity like so busy compiling that I cannot? Thank you. I need more sugar in this tea. It's a little dry, but maybe I should be okay drinking more neutral tea. What? Not implemented exception? What? Excuse me? Does Unity's native list throw a not implemented exception in get enumerator? Yes. Why? What? It's right here. Why not just call the native array one? What? Okay. Okay. Oh. All right. Well, this is informative. It looks like it is empty. It contains 0 elements, I think. Okay, I just need to double check that to make sure. I made a mistake somewhere. Or I'm just forgetful. That happens a lot too. Yep, count shows up as 0. Okay, so okay. But what if I call get instead of peek? Because if I call get, it's actually gonna recalculate if it's dirty. Because then we can tell if that's the problem, or if it's our recalculation that just isn't working. Oh, it does have values now. Oh, hold on. Hold on. We got numbers, and they are all very, very large. These are enormous numbers. So that's probably not ideal. This suggests to me that our job is not actually iterating through the selection properly. So I'm guessing this is int.max value. Okay. Why does your console look so nice? Two things. Okay, one, Unity defaults to, well, there's multiple things. You can check to use a monospace font. And by default, Unity, oh, where is it? Is it under the triple dots or something? No? What? Oh yeah, here, under log entry. By default, Unity shows 2 lines per log. So you get these like large, chunky, annoying alternating situations. I don't like this. So if you set it to log entry 1 line, they're all just 1 line instead. And the colors and the indentation here, that's custom. So that's my logging stuff. I've just made it so that the the indentation of the log is related to the stack depth that it's currently in, which is useful sometimes. You can kind of get a sense of like the hierarchy of everything. And then the colors is just like rich text tags. That's so fucking genius. You know what? I would not call it genius. This is just me refusing to use a debugger. Okay? I just have emotional attachment to print debugging. That's all it is. Okay, so why does this not get the correct length? Do we even get here? I guess that would be good to know. And let's see. It would be good to print the number of selected verts. Writer? Hello? Hey? Can I get any? Thank you. Oh, this one is, you have to think about this one. This one, there we go. Okay. Num 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 num. Anything else I need to? Oh yeah, after this probably. Just in case there's some weirdness happening along the way. Oh, actually, I never dispose of this. That is actually a problem. We need to do that. We do that in here. Do you ever use the Editor Console Pro plugin? I remember using it a long time ago for a short while in some projects, but I don't use it personally. Okay. What are we getting? Selected vertices count 0. This is the problem. So is the enumerator just not doing? That's kind of weird. A little suspicious. Oh wait, hold on. We're even passing count into it. That's gotta be... So count is also 0. Or was it just because I literally just didn't have anything selected? Okay, now I'm really confused. Now it's not even printing when I change my selection. How's Salad? He's doing all right. He's napping right now, though. Okay. Do I wake up Salad to show him on camera, or do I let him nap? That's. I'm gonna put this moral judgment on all of you. You're the ones who are gonna be liable if I wake him up. Let him nap. Must not be woken. Wake. Told everyone about the salad Thor Gumbo toast relationship. It's a complicated relationship. It's quite a lot to cover there. Yeah, he's right next to me over here in the cat tree.
Hey, Salad.
He looks very tired. Okay, you know what? You know what? He is actually awake. Well, he's awake now because I started petting him, but okay, hold on. Give me a moment. Give me a moment. Okay. Salad in T minus I don't know how many seconds.
Buddy. Hello. Come on, Salad. Ooh, you boo. No, 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 no. How you doing, Salad? Hello. Oh, you toast. Show beans? Is it possible to show beans? No. Beans. Beans. Here we go. Got some beans here. Okay. Okay. Hello, buddy. I'm bothering you. Does Ella know we love him? I would hope so. His one brain cell is working very hard. So nobody knows what Salad knows. Not even Salad. I can also show you his brother. His twin brother. Here he is. Baby toast. Okay, okay, okay. You okay, Toast? Okay, he seems fine. Hey, that was a pretty loud bang.
I think he hit his hip on the way down. Anyway, thank you for the raid, Pika. Hope you had a good stream. I hope you showed people your fan art of Salad. You even caught the nose freckle. That's his one brain cell. Or maybe that's where all his brain cells went. The nose freckle is important, that is true. Okay, apart from the occasional cat, I am working on a 3D modeling tool. So yeah, I'm making a 3D modeling tool, and since a lot of you are probably artists, the goal with this tool is that it's sort of supposed to be the Procreate of 3D modeling, in the sense that it's supposed to be nice to use for a very particular target audience, which is, in my case, game developers. So it's kind of like a more user-friendly 3D modeling tool specifically tailored to game development. Yeah, that's what I'm working on. So it's initially it's going to be very focused on polygonal modeling, so not really like ZBrush. Yeah, I haven't gotten that far yet, but still working on getting basics in. But I do have certain things like extrude. Look at this. It does what you would expect it to do. Probably very uninteresting because it's just a basic extrude, but there you go, extrude. Got the loop selection stuff, which might be broken now. Oh no, it does work. We got edge loops. We got real-time selection previews. So if you want to subtract from a selection, you can just like carve out selections. Same thing for face selection. Yeah. And then I've also got a special selection mode called half edge selection mode. So the 3D modeling tool is called half edge, and I'm making half edge a selection mode in the tool as well. So this is me selecting half edge elements. And most 3D modeling applications use half edges in the underlying like data of the mesh, but they usually don't let you select them, which I think is a shame because they're super useful for so many different things like under the hood. And so I've been kind of curious to like experiment to see what happens. What happens if I expose half edges to users? Then maybe there are certain things you can do that you can't do with edge selection. So for example, let's say that you want to cut a mesh open around this half edge ring. Let's say you want to like cut this mesh open and then move these vertices. If you do this with half edges, you can select which side of this edge ring that you then want to move afterwards. But if you just do this with edges, it's kind of ambiguous which edge which side of the edge that you want to grab afterwards. There's also certain like special cases. Let's see, is there a good example I can think of? Okay, this code might be broken. So give me a second. So if you have a bevel, for example, ignore the weird wedge here. If you have a very small bevel, it's quite common that you want to do something like make this soft shaded, but you want it to be flat on top, and kind of be flat along these cylindrical edges as well, right? but there's not really a nice way to do that, at least not with the usual like soft edge systems. So if you make this soft, and you make this soft as well, the shading looks kind of garbage. Like, you kind of get this goopy looking thing. It just makes the top smooth as well. Kind of like a rounded dome here. And it makes these sides kind of weird and goopy as well. But usually you just want to have the bevel on here. And this is actually something that you can do with half edges, where I don't have all the nice selection tools for this yet, but I believe if I select, let's see, is it these? I think it's these. Yeah, I think so. Hold on, yeah. Okay, so if I select all of these half edges, I don't know if this is gonna work, but no, I've even removed the button for it, so I don't think I can do it. Or is it this one? Okay, it's either gonna explode or it's gonna work. But the idea is that you can select sides of edges and then basically say, I want this to be soft edged, but don't let this face influence the vertex normal at all. So that's going to make it so that this face is the only face that contributes to the vertex normals here. And the same thing goes for these faces here. So if I press that button, it did not fully work. It worked at some point in time, but because I'm still working on this, everything is kind of half broken. But yeah, so stuff like that. And I think down the line, I would probably make it a bit more convenient. So like if you select, like if you select a face loop like this, it would be nice if it was just like one button press from here, so you don't have to care about half edges. But yeah, half edges is kind of an interesting selection system because it is what is used underneath the hood, and I think there's some kind of interesting design things you can explore with half edges. So yeah, and there are some 3D modeling tools that do have something similar to half edges. So I believe Maya called them vertex face selection, which is a really weird name for it. Which did let you set certain explicit values for, like, if you wanted to paint vertex colors for only one internal half edge or half vertex, you could do that in Maya. It would kind of like separate your mesh into separate faces. But yeah. The thing I'm working on right now, though, is specifically, I don't know if I have a good, do you have a good drawing of it? What am I doing? Where am I? I don't really have that. But I'm working on soft selection. It's a soft selection system. And soft selection is kind of, it's complicated if you want to use, if your soft selection should follow the shape of the surface. But you could also do soft selection that's kind of like an expanding sphere from your selection. And so the surface-based distance fall-off is known as a geodesic distance, which is a lot more complicated to implement. But so I've just kind of opted to go for the Euclidean distance, where you can see that the geodesic distance, if you imagine this S being a mesh, the geodesic distance is this green distance here, but the Euclidean distance is kind of just like the straight up distance between the 2 points. So right now I'm implementing the easier version first, the Euclidean distance, into this. And so what I'm expecting to see right now is that if I switch to soft selection, I was hoping I would see, oh my god, wait, did it just start working? Hold on. I'm actually getting values in these vertices. Or no, wait, it's not updating when I... I know why, actually. Anyway, this is what I'm debugging right now. I'm looking at the colors of the vertices. When I switch to soft selection, I want to have a gradient from your selection outwards. And it kind of looks like I actually do have... You can see that it's black here, and then it becomes brighter here. Okay, so that's good news. I believe that means that our... I think I know what it is, actually. I think I just don't set... Yes, that's it. I just forgot to mark it as dirty. That's it. Okay, so we're gonna do this dot soft selection distances, mark dirty. I guess we should do that here too. I feel like these should be in the same function. Do we do this anywhere else? Not really? Okay, let's try that again. But yeah, that's what I've been working on today. Doing the geodesic distance, like the along the mesh surface, along the mesh soft selection, requires a lot of math. And so the past few streams I've been looking into exactly how to do that. And it's all of that is based on something known as the heat method for distance computation. In this case, it's going to be geodesic distance, which is based on this paper. So a few streams back, or last stream, the stream before then, we were reading through this paper. Loading. There we go. Yeah, so it's kind of a cool idea. It's really neat. The idea is basically this. This kind of summarizes the whole process. And it's kind of neat that like the way that it works is that it's based off of the way the heat propagates through materials. So if you imagine my selections, if I select a vertex, this vertex is going to be considered a source of heat. So you can kind of see this heat fall off here. And if you have heat simulated from a single point in a mesh, and you solve that like mathematical problem, and if you let that heat distribute over a very short amount of time, like just the shorter amount of time you let that heat spread out, the shape of that heat, like the way that heat is spread out across the mesh, is pointing along the shortest distance to every point in that mesh. The closer that time is to 0. You can't set it at 0. There has to be some non-zero value there. But at its limit, the kind of the gradient of this heat follows the geodesic, the surface shortest distance. So this green line right here. So if you imagine this was the heat source, we would get vectors pointing along this green path, which is a really cool concept. And it's super unintuitive to me that you would get like that these arrows would actually point along the shortest geodesic distance. But yeah, and then like actually computing this though is non-trivial, but this is kind of the outline of the heat method. Yeah. I'm curious how that is different than a complements SDFs. I mean, it is a distance field. It's just that it's using geodesic distance rather than Euclidean distance. Why is this so slow? Trying to see if there's anything I want to talk about. Anyway, but yeah, that's that's the paper. I'm going to send you the links to that in case you're curious. So we've been going through that, but now I'm just going back to the actual implementation in half-edge to make sure that I can actually implement it and not just get stuck in math forever. Okay. So this is a little bit weird. These are not the distances I was expecting here, but we are getting some kind of data. Every vertex has its own vibe. Okay. Got my salad. I'm going to bed. All right, Picat. Thanks for the raid. Hope you enjoyed the few moments of salad. I'm very lucky that I get to experience salad every single day. And like unironically, like salad actually does make me laugh almost daily because there's always something. He's always up to something, and then it's just he's just a very funny guy. Salad's great. So all of these vertices are now colored based on their shader. And right now I'm visualizing the fractional value of distance, which is just the decimal. So let's go back to doing the distance now that we are actually getting data. Okay, so now it's... Okay, it looks like we did get data during our first selection, but then we're not getting any new data. It's a little bit weird. So why is that? We are getting... That's strange. So it is updating the distance function, but it's not... It doesn't seem to reflect, or it doesn't seem to upload. Oh, actually, it might be because it's not marked as dirty. So let's do that. That would make sense if that's the problem. Would you say you're an expert cat reader? Can you look at a cat and know what's up with it? I wouldn't dare to say that I'm an expert, but I've been hanging out with cats for like all my life, so I would probably be able to read cats a lot better than someone who has not hung out with cats. But also it kind of depends on the cat, because they have their own quirks and ways of communicating. So it really depends on the cat, but there's some universal stuff, of course, that a lot of cats share. Okay, this looks good. This looks good. Look at these colors. We got black on the selection, dark gray, lighter gray, white. This is actually looking like a proper distance function. Neat. Okay, I believe we have some kind of soft selection. Okay, let's increase the radius. The fall off distance. Let's double it. Did that make any difference? Oh wait, I'm just drawing the distance. Okay, I should have done that, I think. There we go. Hell yeah, look at that. This actually looks kind of like a soft selection. We're getting there. Okay, so it's like one vertex. We got this whole thing. Okay, that's a pretty big fall off distance though. Neat. Now we just need to actually make use of the make use of the soft selection, because right now we just don't. Okay, that should not be too much work, I think. So that would probably be somewhere in the manipulators. Vertex. We got our initial vertex positions. Okay. Set vertex position. Okay, so we got the delta. Yeah, theoretically, we should be able to just scale this whole thing down. Based off of that weight. Okay. So if we're in soft selection mode, which would be, do I have selection here? Scene? Okay, geo editor. Writer. Come on. I just want the current scene. Viewport state. No? Yeah? I don't understand why writer is so slow. Why is writer so slow? Oh, I need to do dot value. I should probably have a shortcut for this. This is a very, very long one. Maybe a program restart will help? No, it's like this every day since I updated a few months ago, or a couple months ago. Scene.selection? 936? Oh, down here. Yeah, although that's not the soft selection state, but it is the actual soft selection distances. That should be in scene.selection, I believe. Or no, that's no, scene.selection, that's your selected objects. We want the element selection, which writer, are you, does this throw you off so much that you have to restart an entire computation every single time? Oh, actually, right now I only support soft selection for vertices, so it's a little bit more messy. I'm just gonna make sure I'm in vertex mode. Actually, let's just do get. I got that backwards. Okay, so this should give us the... Yeah, let's just do data. Or no, I shouldn't have to do that. Let's see if this works. I already forgot the type this returns. Dynamic gbuffer. I guess I can just do this. Soft dist. I really wonder the end goal here. Sure, this is used somewhere, but I wonder where. End goal for what? Long-time viewer, first-time chatter here. What'll be the target user pool for Half-Edge? Do you tend to make it usable in productions? Yes, the target audience is mid to small developers who are making games that do not require ultra-high poly AAA graphics. So any indie team, pretty much. Any non-Unreal Engine indie team, I suppose. Unreal users tend to like the high poly realistic graphics stuff, but yeah, so anything like a mid poly, mid to low poly. Yeah. Specifically for game development, it is not intended for like animation or something or movies. So it's going to be super, super focused for game development. You're probably going to be able to use it for stuff that's not game development, but then you will be a little bit outside of my target audience. Do you have any sort of planned ETA? I have failed over and over again to meet my own ETAs, so I have no idea. It really, really depends. But you want to do it cost money? Yes, it's not going to be free. Small devs don't have money, at least in my country. So I'm gonna be releasing it almost certainly on Steam. I think, yeah, probably like on Steam and on itch. And it's gonna be a one-time payment. So it's gonna be kind of like the same model that, well, Procreate has, like a one-time payment. And things like Sprite. Yeah, that model. You pay once and then you have it. It's a very radical model in this day and age, but and then I'm thinking like after 1.0 is released, I would probably increase the price when I add more features. So it's going to kind of scale based off of the feature set. Is there a video showcase for how it looks or how it works? Not really, beyond like looking at my streams, I suppose. I've done a few interviews and whatnot about Half-Edge, but there's not like a good summary in one place because it's still a work in progress, right? Will it have regional pricing? I believe it would on Steam, but I'm not sure about itch, if you can have that on itch. But yeah. Season Pass could add skins for widgets. That's true. Honestly, I feel like some people would probably buy that. So yeah, maybe. I don't think you're too far off. Maybe. Why would I use it over something like Blender? Meaning, what is the KSP for it? I think ask an illustrator why they would use Procreate over GIMP, and I think you'll have your answer right there. The like I will never ever be able to compete with Blender on number of features, right? That's going to be impossible. That's just a physics problem. That's not going to work, right? And so the edge that I have is that I can make something that is a little bit more modern. It's made for game developers, and it's a little bit more focused on the things that game developers care about in terms of feature set. Because Blender is huge. Blender is an enormous amount of things at once. And it's honestly kind of intimidating, even if you've used like Maya before. And so the idea of Half Hedge is that it's going to be a lot more of what's going to feel more like a clean slate, a small feature set that's really, really focused and feels nice to use. And I think that feels nice to use part is really hard to explain unless you've used it, you know? Because it's like I said, Half Edge is never going to look better if you look at a list of features comparing them. And the same goes for Procreate, by the way. So if you compare Procreate to something like GIMP, Procreate is very bare bones, but using Procreate feels amazing. It's great to work in. It's enjoyable to use Procreate. But if you're an artist using GIMP, most people don't like using GIMP for art. Like, there's a reason GIMP is not... Like, I don't think any artist will ever mention GIMP as their, like, favorite drawing tool. I don't think there's a single artist out there. I've yet to find one. Usually, it's, like, anything but. If I'm not experienced with any game engine, do you still recommend me to learn Unity or better avoid headaches and go for Godot? I'm not sure, honestly. I don't know where the market is heading. I don't know where Unity is heading, and I don't know where Godot is heading. I will say though, a lot of your skills are going to be transferable between Unity and Godot. So I don't think it super matters which one you learn. But yeah. But Unity obviously has a lot of Unity has a lot of projects in it, and a lot of companies use Unity. But Godot is growing in smaller communities or people starting out, so I don't know. Go for whatever. Sayang Mo, pixel artist, swears by GIMP, FYI. Well, I guess that just destroyed my entire argument. Okay. I don't right now the fall off stuff is kind of separated between the GPU and the CPU, which is not super nice. Do I calculate the fall off immediately? Okay, I'll just copy it for now. To do unify weight calculations. Okay, soft distances. Ryder? Ryder, hello? Wake up. I pressed on indent several seconds ago. What are you thinking about right now? What is happening? What is... There we go. Okay, good job. I'm losing my mind sometimes. What was I doing? I wanted the... Right, vertex ID, get the soft distance. I guess I should do data. And then math not max. Oh, we got syntax highlighting now. Getting a job in game dev is pretty rough now, regardless of what skills you have. It seems kind of rough out there, yeah, from what I've heard. Okay, so we got the selection weight, and so now we just need to modify the delta. Rotation is a little bit trickier. And my rotation, like, gizmo is broken now anyway, so we actually don't need to care about the rotation. We can just do the translation. So all we need to do is we scale that by the selection weights, I believe. Okay, okay. Why do you feel the need of making your own 3D tool? This is just a fun project of yours. It's a combination of a lot of things, but well, it is a combination of I do enjoy a challenge, and I really enjoy mathy tech art visual stuff. And so making a 3D modeling tool is a really good like culmination of all the different things I've done in game development in one place. And so that's one thing. I also want a 3D modeling tool that is not Blender and that does not cost like half of my salary per month, like Maya. So I also kind of just want a 3D modeling tool myself. So, and then also I do genuinely believe that there is a market out there for people who think that Blender is annoyingly complicated. Even people who use Blender sometimes tell me that they don't really like how complicated it is, even if they've used it for like a year or two. Yeah. And so I think oh, and another thing with a half edge is that I also want to use the industry standard controls for all of this stuff, because the because Blender uses different controls than Unity and Maya, and so I'm very intentionally trying to make it so that going between like Unity and half edge should be very easy and seamless. Or whatever tool you're using. I have considered adding like camera support for other types of editor cameras, but I haven't fully decided yet how to do that, because like hotkey design is a very complicated subject because it is crowded on the keyboard. So we'll see how that turns out. Okay, soft selection does not work. Did I compile? Hmm. Why does this now work? Oh wait, maybe I didn't compile. Will you add half edge as a package to use an editor too, or only standalone? Only standalone. It used to be a Unity plugin, and then for a while I tried to make it so that it could be both a plugin and a standalone application, but maintaining that was really annoying, because there are so many differences between how you want it to work in standalone versus in editor. So I just decided to like not make it too complicated for myself, because this is already a huge undertaking. So it is only standalone for now. Okay, soft selection. Why? Why is it not working? Hmm. Why is that? Hmm. That's a float. We should be getting the soft selection distances. As long as there's a focus selection button, I can get used to any camera. There is a focus selection button. Look at this. Why isn't it working? What am I doing wrong? Am I stupid? Hmm. Do you think it would be possible to add a keyboard-only mode that can be used without a mouse, like a Vimeo workflow? It would be incredibly useful for RSI-plagued people like me. Definitely not prioritized. Yeah, I don't have any plans of doing that for now, but maybe in the future. Can you implement AI? Nope. Why is this not working, though? It's not that this is like... No, it's not. No way this would be an integer max for some reason, just because I have 0 here. Okay, I'm gonna print. We're just gonna make sure, like, does it actually do anything here? Are we getting any weights? Weight. That's how you spell weight. Oh, hold on. Hold on. Okay, this makes sense. That makes sense. Okay. Okay, so the problem is that when I do this, I'm only iterating through the selected vertex, the selected vertices. That's the problem. So yeah. Yeah, okay. So here I'm converting the selection to vertices, and I'm collecting all the vertices that I want to move. So here I'm going to have to collect the ones that have a weight that's greater than 0, right? Okay, this means we're going to have to generalize this a little bit better. So I'm going to be turning this into a function. Get selection, or get, selection weight for a specific vertex of vertex. I miss solving code problems with my brain, but I simply just feel like crap solving problems that AI can solve for me in 30 seconds. Well, the secret is to just not use AI. Just don't do it. Just say no, you know? It's that easy. Where did I put my code? Where's my AI that would tell me where I was, what I was, and what I was supposed to do? Okay, here it is. All right, we're good. Okay, soft dist. Where did we get that from? That was this whole situation. Okay. Maybe I should just store the weights, actually. Initial vertex positions. I wonder if I should make these a vector 4, and then the W component is going to be the weight. I think that makes a lot of sense, actually. Yeah. Let's just see what happens if we do that. Okay, convert selection to vertices. So this gets us only the fully selected vertices. And then I guess I need some way to check if soft selection is on currently. And I feel like this is a bit of a mouthful. This is way too much just to check. Is there a nice way to do this? I guess I would put this into a property somewhere. Maybe an element selection? Yeah, it would be in here, I think. Public, bool, soft selection on. Current selection. No. Current scene, which would just be scene. Scene dot. Right, it would be the viewport. Viewport 3D state, use soft selection is not equal to, no, dot value, not equal to off. Okay. Cool. So now we should be able to go through the selection instead. Okay, so this is going to be current scene. No. Do I have selection somewhere? Selection? Selection? No? Okay. Scene? No? Yeah? Actually, there should be a scene. Selection. Did I put it in the wrong selection file? Did I put it in geoselection? I did. It should not be in geoselection. Or no, wait. Maybe? Now I'm confused. Scene.selection should be... Oh, that's the wrong one. It should be element selection. There we go. Good lord, writer is so slow. I don't understand why. Hello? Any kind of... Okay, alright. Okay, I'm starting to get tired. My brain is zoning out every now and then. Let's see. Soft selection on. That's all I wanted to get to. Writers using AI to increase your productivity. Do you feel it in your bones? If the slowdowns are due to AI, then I absolutely feel it in my bones how they're trying to do that, yes. Okay, so. Alright, all of this should work just fine. What we need to do now is that we need to... Let's see. Verts to move is a hash set of all of the vertices that are selected. So I guess we don't... I guess this would kind of be like two different paths, depending on if we have soft selection on or not. So if... Jesus Christ, my computer is just like struggling to do anything. Is it because I have the game running at the same time? Is it because I have like a gazillion tabs? Do you want me to close everything, writer? Okay, yeah, because you need to think about every single tab. Is that the problem? Where was I? What was the file I was in? Where's my AI that would help me in this situation? Ugh. I was in the manipulator. See, I just had to think. That's the trick. That's how you escape the need to use an AI. You just need to stop and think for like 2 seconds. And then you're good. They don't want you to know. Clear cache too? Well, I'm not sure about that one, because then what if it has to rethink everything? Oh my god. Okay, if soft selection is on, then we want to do one thing. If it's not on, then we would do what we used to do here. Initial vertex positions. Why is this a vector 3? I feel like it should be a float 3, and this should be a float 4. Hmm. Posture check. Fine. Okay. Clear cache. I don't know how to clear the cache. Tools. Help. Diagnostics. Is there an action search? Clear cache. No? I don't know the action search shortcut. Really, it should be under diagnostic tools. Well, it's impossible. There's simply no way to do it. And file? File? Invalidate cache? Is that the one? How many things do I want to check? File system cache and local history? Do I want to check that one? Writer randomly uses 30% of my CPU in idle. Yeah, I don't get it. Like, I can hear my computer, like, spinning up the fans randomly. I'm like, why? Two first only. Okay. Oh, do you find AI useful in Obsidian, or do you prefer not to use it? I prefer not to use AI for... I don't want to use AI for anything creative, and I don't like using AI for anything that substitutes me needing to solve problems on my own. I don't like problem solving using AI unless I have an incredibly boring, mundane, weird Windows issue. Then I might use AI to see if I can like find a solution online. I think the primary use case for AI for me is like it's a search engine. But AI for anything creative? No. That's like absolutely not. Like that to me is like that just like it takes away the entire point of why we do art and why we like enjoy problem solving, or at least I enjoy problem solving. Maybe I'm a weirdo, but like that, I love learning things. I love problem solving. At least if it's like within my sphere of interest, I guess. I guess I do. Yeah, like I said, if it's like I have some weird hardware problem or like a problem in Windows and maybe I can find some kind of solution through AI. I'm fine with using AI for that because there's no creativity involved and there's not much of value that I would learn if I were to problem solve this myself. And it would take too long probably. Yeah, so sometimes I use it for that. So there you go, fans of AI. That is my use case for AI, but that's about as far as I go. Can you ever use it for inspiration? I mean, you can. The question is whether you should. Um, I use it to write out a switch case for an enum list. I mean, you don't really need to use it for that. That's a built-in thing in Writer. Okay, have we cleared all the caches? Are we performant now? Okay. So let's see. If soft selection is off, that means that the vertices to move is only what? Is only the selection that we have. But if we are using soft selection, then we also need to include the other vertices within our soft selection. If that is the case, then we don't actually no, maybe we need to do this. Or no, we don't. Or I might have to in the future. We'll see. But right now, selection is always in vertex mode. Actually, I should probably add that as an extra condition here. So element selection. If that is no vertex end. There we go. To do what? Remove vertex restriction down the line. Have we checked task manager? Well, I'm not sure what to check there. I mean, I can see that writer is randomly using a lot of processing power, but okay. Cool. So if soft selection is on, then theoretically, we just need to iterate through all of the weights. Because that's kind of the only, or the distances. Yeah. Let's see, initial vertex positions. What is this? Oh, it's a dictionary. Okay, that makes it easier. So then it's going to be a for loop over the, I guess, every vertex in the mesh. Yeah. Mesh dot vertices. Okay. And then we need the guess I'll just call that for all of them. And then if weight is greater than 0, then we include it. And in initial vertex positions and in verts to move. I forget, is that that's a hash set? Okay. I guess I could just use the keys of the initial vertex positions instead of also having the verts to move array, but whatever, it's fine. It's okay. All right, grab the vertex position, and then we'll set the weight as W. Cool. What's the model of that mic? It is an Avantone CV12. Okay. This should be a float 4 because it's a start position and weight now. We're right. Hello, keyboard. Fingers, cooperate. Okay, and now we don't need to do that. Actually, we don't need to do... Or no, I guess it would be good still, actually. We can swap this out with just that. Don't need all of that. Actually, it's kind of unnecessary to have that. It's going to be... I don't know. I don't know. Okay. Is that it? Are we good? I think we might be good, actually. It looks very post-Soviet grungy, but also kind of pretty. Post-Soviet grungy. I don't know if grungy is the word I'd use for it, but... Okay, are you ready to see some code that works? Soft selection. You ready? Alright. Hell yeah. Hell yeah. We've got liftoff of the basic ass soft selection. Oh, and I got rated right as it started working. Hello, Soding and Soding's folks. I am making a hello everybody. I am making a 3D modeling tool. Yeah, and I'm currently working on implementing soft selection. So I just got it working. Like right as you started the raid, that was the first moment soft selection actually started working. So I don't know if that was intentional, but very good timing. Good job. Okay, so right now the soft selection has a linear fall off, so you can see that it's kind of creating this straight line. So that's kind of the first thing we should fix, but that is not a problem. That's easy to sort out. So all we need is, where's my browser? I would like a browser. There we go. Okay, so Desmos. I always forget the order of this, so it's like 2x cubed minus 3x squared? Okay, I got it the wrong way around. So 3x cubed 2x... Or no, squared 2x cubed. There we go. Okay, look at that. Smoothing function. Also known as smooth step. What is soft selection? So when you don't have soft selection, if you select a bunch of vertices in a mesh, you're moving only the things that you selected, right? But sometimes if you're like doing something like editing terrain or anything like organic or soft, if you enable soft selection, you also move neighboring vertices. So that's soft selection. Yeah, and so that's what I'm working on. And right now it's very linear. You can see that it's kind of a straight line, which is not super cool. So I'm just going to add a bit of a curve to it to kind of approximate a bell curve. Does not have to fall according to quadratic function or bell curve. I mean, it could be anything, right? It's just up to the user. Using an actual bell curve like the normal distribution, it's a little bit annoying because the normal distribution extends to infinity, and I don't want it to extend to infinity, right? I do want to have a maximum distance. And so I'm just going to use that. That's the cubic smoothing. So that's here, get selection weight of vertex. So this is our normalized t-value, I guess, and we clamp it here. So I guess we apply the smoothing here. I might actually already have the math function for that. I do. Smooth 0, 1. That is almost certainly the equation that I just wrote. Yes. Okay. Selection weight equal smooth 0, 1. Actually, linear selection weights. And then return the nonlinear one. Does ZBrush use soft selection as its primary sculpting method, or is that something else? It's very similar, but it's a little bit different. Like the like soft selection is kind of like if you're not using a tablet pen, if you're not using an actual brush, then soft selection is kind of a way to get a similar type of editing. But ZBrush has more of a like sculpting workflow where like you're kind of dragging your pen along a surface and you want to like create a bump as you're dragging it along. So for sculpting, there is kind of a time dimension to it, and it's not like you have multiple different selections in multiple different places. It's just a single point where you're kind of stenciling this brush shape onto it, and then you're like extruding based on that. Which is similar to soft selection, but soft selection is more about you have selected specific primitives, and then you want a like softness spreading out from that selection. So, but they're for sure related. So like in a sense, the thing I'm doing here is that I'm choosing what quote unquote brush to use. Like what should the shape of the fall off be? Yeah. Okay, let's see if that worked. A lot of people have been asking if this is the same as proportional editing in Blender. I don't know what proportional editing is, but maybe. Possibly. Okay. I did not mean to select that vertex. Soft selection. This is a bad shape to test this on. Okay. Well, let's do torus. That's not a torus. Okay, let's just grab this line right here. Zoop. That's looking a lot smoother. Look at that. Look at this goopy thing. It looks like some kind of toilet attachment. I don't even know. But it looks smooth. And that's neat. Hell yeah. Okay, so I think the next step of this would probably be being able to adjust the radius or the fall off radius. Looks like one of those co-working chairs. Potentially. I don't know what kind of co-working chairs people have, so looks like the bean. Okay. I'm actually really happy about this. I'm glad this worked. I guess I don't apply it to scale yet. Yeah, I don't apply it to scale and rotation, so that's going to be the next step for after I've fixed my rotation gizmo. Because my rotation gizmo is just not happy right now. If I rotate stuff, it just kind of goes off into who knows where. I don't even remember what refactor I broke this in. So somewhere along the line, I broke my rotation stuff. It just kind of leaves. It just leaves. Bye. Not even the trackball rotation works. Not even the camera rotation works. It's yeah, it's over. Do you ever write tests? Nope. I do not. Okay, I need to ask. Has anyone had issues with either Unity or maybe Writer? I don't know. Or maybe Chrome, where something on your computer is making you hold right click. Like right now, I am not holding right click, but it's acting as if I'm holding right click. I have no idea why this is happening. And I've even gotten a new mouse, so it's not hardware. I know that now. It's not a hardware thing. So it's gotta be software. But I have no idea where to even look to figure out how or why or anything. Do you have a controller plugged in? I have controller drivers, but I don't have a controller plugged in now. Unplug all of the USB devices. I have so many USB devices. My pen tablet is plugged in, yes. Same brand mouse? No, different brand. So you're saying I should like binary search all of my USB devices, is that it? Could be the thing where when you release the mouse button, while Windows thinks that the window is not focused, so the Windows doesn't correctly handle the release event. I mean, that's what it feels like, but I don't know who is doing it. I know that it happens even when Unity is closed. I don't know if it happens if I don't have any Chrome windows open or if I don't have any Writer windows open, because I almost always have Writer and Chrome open. But it feels like it happens more often when I am in Unity, or it's because I'm using right click a lot more, and that's because, and so I just notice it a lot more. Try Control Alt Delete, and then what? Oh yeah, now it happened again. Oh, and if I right click, it goes back to normal. And it's not only in the 3D editor, no. If I'm not in Unity, it can still happen. Unity can be closed, in fact, so. Oh, Control Alt Delete resets it. Okay, I opened the task manager, but it's still holding right click for me. Or is Control Alt Delete like a different? I guess that's like the login screen and everything. Okay. Okay, well now it's not holding right click, but I did press escape to close the lock screen. Yeah, I legit don't know how to trigger it. I did not even use right click here. I didn't even use right click. And now I'm stuck in weird right-click mode. Why? Maybe Bluetooth delay? But, but why would it start all of a sudden? I don't know. I feel like I would experience so many more issues if it was just that. Does it enable when holding right click for X seconds? Holding right click, but no. I'm pretty sure it's accessibility, mouse, click lock. Is it this one? Accessibility insights? Or is it separate from that? Oh, this looks very... Never touched this before. I'm guessing it's a different thing. Mouse settings? Mouse settings? Mouse click lock. Accessibility. Click lock is off. Yeah, I don't know. This seems off, right? Accessibility keyboard. I don't know why it would be sticky keys, because I haven't changed that setting as far as I know. Sticky keys is off. There's a debugger attached right now. Well, it says it's connected to Unity. But this also happens even if Unity is off, and I feel like it wouldn't be connected in that case. Like it says connected, but not attached, because I can still press attached, so I presume it's not. Well, I guess I'm in play mode right now. And Writer does detect that, but I don't know. I don't know. I did ask AI as well, yeah, but it was a very vague general answer, but I was kind of hoping for, oh, this is totally this thing, but no. It was kind of like, well, why don't you try to look for everything that potentially could, mayhaps, potentially, somehow, you know? It was like, just search everything. It's like, well, control mouse with keypad is off. It's off. I'm pretty sure we looked at that earlier. Mouse. Click lock off. What else? Mouse keys off. I don't know. Did we rule out that it's Unity? Even if Unity is closed, this happens sometimes. Oh, it just happened again. Wait. Did I just figure out a trigger for it? Hold on. I think I might have a repro. Yes. It's Alt middle mouse. Sometimes. Or, wait, hold on. Okay, does not happen with just middle mouse. Middle mouse is fine. Oh, hold on. We might have a clue. Okay. Okay, we have we've made progress. Okay. If I did I move shift? Control? No. Okay, if I hold Alt and then tilt my scroll wheel to the left, my right click is locked. That's what's happening. I don't know what that's bound to. What's the binding for scroll wheel tilting? I basically never use that. I don't know what input that is. Scroll wheel tilt left input Windows. What is that usually? Hmm. Is this a thing? Probably better off disabling the shortcut entirely. Yeah. I don't even know if I have a Logitech like driver shenanigan. I don't think I have that. I don't even know what it's bound to. Is there any way to like, is there an input debugger where I can like show current input? I mean, I guess I can write one in Unity, but that feels a little much. Should just bind to scroll left, right. Okay, so if I like, can you stop being responsive? I want a scroll bar. give me a scroll bar. Okay, Google's refusing to give me a scroll bar. Does anyone have a horizontal scroll bar? Do we do those still? Or did we stop doing horizontal scroll bars? Are we all so goddamn responsive everywhere? Oh wait. Pressing, tilting the scroll wheel left twice opens up the context menu. It's as if I'm doing a right click. Mm, oh yeah, I could ask the goddamn AI. Sure. Logitech mouse. What input is the Logitech mouse tilt left? There we go. Okay. Mouse button 4 or 8. In web browsers, it's a back command. That is not true. Also, mouse 4 is a different button, so maybe 8 then? It's so weird that this started happening recently. Okay, maybe I just need to install the mouse drivers and then because I haven't done that. Okay, whatever. I'll do this off stream. That I'm guessing it's now I have a clue for what it is. So probably not interesting to watch on stream. And also I really need to go eat. I was so inconsistent too, which was super confusing. So I guess it's anytime I middle mouse button and I accidentally tilt it to the left. That's what's locking it up. Okay. It feels weird to stop stream because I have quite a lot of viewers. I usually don't have this many viewers. Maybe it's the Windows USB plugin sound that popped randomly. I don't think so because this has happened before. How am I supposed to stop stream when viewers, you know? But I do need to take care of myself and have food. Are there any questions or thoughts before I head off? Either about my modeling tool or whatever. I guess next stream we're gonna do the being able to control the fall off distance because now it's just fixed to some value, you know. And then the hard part of doing like actual geodesic distance instead of Euclidean distance. Because right now, our fall off is across Euclidean distance, which is the straight line distance from point A to point B. But in like quite often you want to have the geodesic distance, the distance along the surface, which is much harder to do, significantly harder. But yeah, I've been reading a paper about using the heat equation for geodesic distances. So I'm hopefully getting there. It involves huge matrix solving, which is a bit of a mess, but hopefully we can get it to work. That looks nice. Why would you bother doing geodesic distance? Because if you, for example, if you have a hand and you want to do soft selection on this finger to move something, you want just this part to move. You don't want to like grab the other fingertips and move all of these at once because it's like doing Euclidean distance. So geodesic distance is kind of a way to just like do soft selection but wrap it around the surface at the point you want to do the modification. So it's super convenient for a lot of cases. They're both useful, but they're different. They're just different. Yeah, just different use cases. Do you want to compute those in GPUs? Probably. I'm probably going to start with the CPU implementation and then move it to the GPU. Maybe. I haven't decided yet. We shall see. It depends a little bit on like what. It depends on what method I'm going to use to solve the matrix, because some algorithms are a lot more parallel, which is really good for the GPU. But a lot of like linear system solvers are they're designed for CPUs, which means that they have a lot of like reduction passes where you need to like, I don't know, find the minimum out of 2000 values, which is fine to do on a CPU, but on a GPU it's annoying to do that because you tend to have to do a bunch of like parallel reduction steps and whatnot in order for that to be performant. But the CPU is better at doing that kind of thing. Yeah, and a lot of like parallel like equation solver or like a poisson solver are usually implemented on a grid, but I'm not really on a grid in this case, so it's a little bit tricky. In Blender, I usually have to hide nearby things to prevent them from also moving. Right, yeah, like you wouldn't want to have to do that, right? Have you heard of Gaussian splatting? Yes. Stupid question. Could you walk the edges in some Euclidean edge length? So first off, I disagree. I don't think that's a stupid question. And second, no, you cannot do that because the shortest distance, if you imagine this white thing here, if that's kind of like a U shape, shaped like this, if you want to get the shortest distance from this vertex to this vertex, the geodesic will go across a face, across some position of an edge, diagonally here, across here, and then across this edge. So this geodesic is shorter than if you were to traverse, like, I don't know, to here, and then down here, and then over here, and then back there. Like this red one is definitely longer. So you cannot just go from like vertex to vertex or like along edges. There's usually a shorter path than that. So this red one would be more akin to the graph distance, but graph distance is not the same as the geodesic distance. Unfortunately. Never considered how it would look like on 3D on non-spherical shapes. Yeah. It is somewhat non-trivial, and there's like specifically for discrete geometry, like this is not like differentiable, right? It's just a bunch of linear like planes connected to each other. There's also the question of like, what do we even mean by geodesic? And there's kind of two different meanings of geodesic. One of the definitions of the geodesic is that you want to minimize the distance. So you want to find the shortest distance from here to here. Another definition is that you want to minimize normal curvature. In other words, anytime you go over an edge, you want to make sure that you never turn at all. You're kind of only going in a straight line. So this should just be a straight shot from here to here, where anytime you go over an edge, you kind of like tilt down like onto that plane without turning left or right and only going straight. In the continuous case, these two are often equivalent, like it's the same path. But because this is discrete, those two are actually different. And so depending on which definition you're using, you're going to get two different types of geodesics. One that minimizes distance and one that minimizes turning. Yeah. But they're usually, in many cases, they're usually the same, but there are edge cases where they tend to get weird. Those aren't the same in non-spheres? I think any continuous surface, they're going to be the same, but this is not a or any differentiable surface. I think they're going to be the same, but this one is discontinuous. Couldn't you subdivide the edges iteratively to find it? Yes, you can, but the problem is when you start doing this on a mesh with a total of like 20,000 vertices and you've selected not just a single point, but you've selected 4,000 vertices. And so now you need to solve this thing pretty fast, right? And doing a subdivision from every single vertex to every other vertex, you're gonna have to like store all of that intermediate topology for every vertex along the way, which is a nightmare. So that's not gonna work. So you just need a different design and a different solution for it that's more parallelizable, because many algorithms, like I don't know, standard pathfinding algorithms are just going to be using too much intermediate data to be efficient for this. Yeah. I have a question about where I can find more stuff about procedural geometry from you. I mean, it's my YouTube channel for the most part. I don't really have any other places where I post my stuff. Well, I mean, I guess I used to use Twitter, and now I'm on Blue Sky, but I don't really post that much like procedural geometry educational stuff. Could you blend these two methods? I'm sure you could, yeah. But yeah, so the strategy for doing this in a way that's hopefully a lot more parallelizable is using something called the heat method. So basically what you need to do is that you need to solve two linear systems. So this one A and this one B. So the heat method is basically, if you imagine like your selection, if you imagine like every point here is a vertex, but you've selected a single vertex here, then if you imagine this being a source of heat, and you let that heat propagate for a very short amount of time, then the gradient of this, in other words, the direction of steepest ascent, is actually going to follow the geodesic to that point. And the shorter that time step is, the shorter amount of time we let that heat diffuse across the mesh, the more accurate it's going to be. Can't be 0 because then we have no values to compare with. But the idea is to find like the optimal, like small value of time for heat to diffuse across your mesh, such that you get useful data for the direction of your geodesic. Once you have this heat value, you can just do the gradient of that to get the vector field, and then you normalize that vector field so it's just pure directions. And then once you've done that, you just need to integrate. And that can also be done using a linear solver if you do it based off of the Laplacian. So it's effectively two Laplacian solves. So once you integrate this, you get the actual geodesic distance from every other vertex. Yeah. So I guess you want some kind of FFT. It was not used in this case, but I've heard that you can use that for certain types of matrices, but I don't think you can use it for every matrix solve. I think you have to meet certain conditions, as is usually the case, unfortunately. But yeah. So the past few streams, I've been doing a lot of reading to try to work out this specific method, which involves differential geometry, which I don't really know that much about. So it's been kind of dense to work through. Yeah. So this is the paper that I've been reading on this. If you want the paper. Does this have anything to do with SDF? Yeah, I mean, it's a distance field. It's just that the distance is in a geodesic distance rather than a Euclidean distance. So it is a distance field. It's just that the distance is in a different space. all of these drawings would make some cool bed sheets or blankets. That would be cute. Can you imagine like someone's kids that has like math scribbles on their bed sheets? Certified fan of math. But yeah, so it is an SDF because it is a distance function. But it's just not really the S part. It's just the DF part. You can extend this to there is a variant of this one that actually does compute a sign distance field, like a generalized sign distance field, which is really cool. And they also work out a way to do like the exponential map, so you kind of get the other dimension as well, which is super, super cool. But that's beyond what I need for this. But yeah. Wow, distance. Imagine distance. Distance is pretty cool. Why does the time need to go as close to 0 to get the actual geodesic direction? Is it just the direction that matters, or the magnitude too? Magnitude doesn't matter. And so I think there's an... Actually, maybe that's not true. I think the intuition is that if you have a heat source and you let it run for a very long time, I think you're going to get a lot of diffusion. But if you don't let it run for a long time, you're kind of going to get the initial propagation. I think that's why you want it to be a short time. Because you don't really want a lot of diffusion. But yeah, I don't remember. I don't think they motivated why it is the case that it follows, but I'm sure they probably cited it somewhere. It's interesting to hear you talk about all that. I'm a complete ignorant, but I love it. Good, I think. But yeah. All right. Any other thoughts, questions before I head off? Does that method generalize to shortest distance to a line region if you diffuse heat from more than a single point? I'm not sure yet. I think so, but from what I remember reading the paper, it seemed a little bit ambiguous. Because I think I remember they mentioned that you need to run the solver for every source, which would be bad, so I hope I don't have to do that. And also, honestly, even if you couldn't, I would guess that the answer is close enough to what I need for it to be good enough for my use case, you know? Have you eaten yet? No. I really need to eat. Is there a reading list for this? No, just a paper that I sent you. This one. Having a hard time finding a time-efficient way to reliably learn anything. What's your learning process? I don't know how to learn things that I'm not interested in. And so I'm pretty much only able to learn things that I'm interested in. So I have zero advice for how to learn stuff that you're not interested in. But if you are interested, or rather, if you're not interested in it, try to make yourself interested in a way. Like sometimes I would get assignments when I was at Future Games. It was a vocational education. It was like 1.5 years. And there, sometimes we would get assignments that I didn't really want to do, but I usually asked the teacher if I could just tweak it a little bit so that I would care about it, you know? So like, I think there was one assignment where we were supposed to like analyze a main menu of a video game, and I asked if I could like, well, can I just make my own menu for my game that I'm working on? So like things like that, where you like kind of modify some of the assignments and whatnot. But I don't know if that's your situation, if like what the reason is for the thing you want to learn, if it's for because you want to do it personally, or if you want to like or if it's an assignment, or if you're at school, or if you're at work and you have to learn something to get something done. I don't know. Would graph distance along the edges of a mesh be close enough, or does it have a really bad worst case approximation to real geodesic distance? It might be good enough in some cases, but I also kind of want to implement the proper version. But I'm sure it's a good enough in a few cases. You were the one doing the cool videos on interpolation YouTube. Interpolation YouTube, is that a community? But yeah, I made some videos about splines, yes. About Bezier curves and splines. What's the time where you live? It is almost 11 o'clock. Or 22:46 right now. I never know which one is AM and PM around 11, 12, and 1. so I'm just not even gonna try. There's like an off by 1 error there that I always get caught up in, and I hate it. You're a late eater? No, I'm just a late streamer. I'm also very hungry. that's the problem. Trying to do Maxwell's equations, but it's painfully slow. I know language is a factor, but I'm trying to rule out ignorance first. Yeah, I don't know. I don't know your situation. Usually when I get stuck doing certain things in, usually when I get stuck with some math thing, it's usually because I've made an assumption about something without justifying it, or like I didn't actually understand something that I thought I understood. So sometimes you have to kind of like zoom out and go back a little bit. Like you should be able to explain every single part of the thing that you're looking at. If you can't, you have to look into one of those things, the thing that you're not able to explain. At least that's how I usually approach it. It's very brute force. And sometimes you get led down like a huge like rabbit hole of having to explain every step along the way. So it's not very efficient, but it does help you get a more fundamental understanding. AM PM is alphabetically sorted. Oh yeah, that is fine. What I think is not fine though, I think it's past midnight. Is it past midnight or is it past noon? No, I think it's noon. If you have like, if it's 12:30, 30 minutes after noon, 12 p.m. That sucks. If like 12:30 should not be p.m. Like p.m. in my mind, p.m. means plus 12. That's what p.m. should mean. But p.m. means after noon. But if it is the case that it's afternoon, then you should just like swap it to like 0:30 instead of 12:30. And so there's this like mismatch between these two different systems, and it sucks. It's bad. Like if you do want to stick to the fact that it's supposed to be post meridium or whatever, just say 0:30, because then you align the idea that PM could mean both post-meridium and plus 12 hours. But now we're in this like cursed middle ground where nobody's quite sure what anyone means when they say 12:30. Because you're like, well, shit, it could be either. Like, there's no way to know. No way to know. Ugh. Us poor Americans get confused because there's no 0 on a clock. Yeah. You don't know how to measure degrees either because, you know, it says 0 here, but then you say that it's also 360. Like, what does that mean? Like, who knows? Who knows what modulo is? Did you see this? Falsehoods about time? Oh, is this the like really long cursed facts about time? Oh yeah, this one. Yep. I've seen this before. It's good. Just use 24-hour format. Yes, that makes things easier, but unfortunately, people don't do that verbally. Even in Sweden. Sweden does use 24-hour format, but not in common parlance. Like, most people would say, like, 8 instead of 20. Like in speech. Like, oh, I'm gonna be home by 8. If you say I'm gonna be home by 20, people are gonna think you're a nerd. Which people already think about me, so I don't really mind, but most people would say 8. Anyway. Oh, sorry, I missed a bunch of questions. Finding it hard to navigate all the technical and mathematical prerequisites and the diversity of paths for tech artist, graphics programmer. Do you have any words on that? Don't feel like you have to learn everything at the same time. Because like game development is one of the deepest fields of any other art form. There you can go an entire lifetime and never learn everything there is to learn in game development, because game development is so broad, super broad. So yeah, I would just like learn what you think will be useful or what's interesting to you and whatever gets you motivated at first, and then everything else is kind of going to follow naturally, I think, once you have your legs, so to speak. Like the most important part is that you should get to a point where you can do things on your own, so that you can start like developing a sense of the language and how things interconnect with each other. And get your hands dirty. Start doing things. I think there's a lot of people who get stuck in like only reading about stuff or only watching videos about stuff and never actually applying it. And I think that's a trap that some people fall into. And you're never properly going to internalize something unless you've actually gotten your hands onto it. You need to make things, right? It's kind of like honestly, it's the same with almost any other art form. You're never going to be a good artist unless you do art, you know? You're never going to be good at math unless you start doing math. So yeah. Make sure you do stuff and make sure you're excited to do stuff. Since all meshes must be discretized into a graph-like structure, does that mean ultimately all geodesic distance calculations have to be approximated with graph distances? No. The heat method that I'm using now is basically using the discrete Laplacian. So it's actually doing like a Poisson equation solve using the discrete Laplacian across the mesh data. Do you drink enough? No. I am very bad at drinking. I can sometimes go through like a whole day and I'm realizing I've only had a single cup of tea that morning. It's really, really bad. I don't know why. I don't like I can even be thirsty like all day and not drink anything, but I am actually thirsty. I just never act on it. It's really stupid. I don't know if I'm just really bad at like reading my own body or caring about my own body, I guess. Um or I like sit and do stuff and I'm like freezing cold, or I need to go to the bathroom for like a really long time. And I just never act on it until it's way too late and I'm like, holy shit, I feel garbage. So I don't know. Really, really good. That's neutral fasting at work. No, there's a lot of reasons that could be the reason for why you're not eating enough or why you're not drinking enough, and sometimes it could be for bad reasons, right? I do have a water bottle. It has helped a lot. Oh, self-heating mug has also helped me drink a lot more tea. Because I drink very slowly, so my tea tends to get cold way too fast. So if I have a self-heating mug, that's not a problem. So I just have the charger at my desk, so it's just like sitting in the charger all the time. I super don't like this mug though. The firmware just doesn't cooperate with Android, or at least not my phone. I don't know why. Okay. Oh, just make sure if you do get a self-heating mug, get a mug where the heating element is in the mug itself. Do not get the ones where the pad you put it on is the source of heat, because those are super inefficient, and usually they don't even make it that warm. So you want one where the heating element is in the mug. Plus, then you can just take your mug to the living room and like have your self-heated tea for a few minutes. I feel like mine has like dropped down to like what feels like 10 minutes at most, but it used to be like an hour. But okay. How do you learn this fancy math stuff? I do a lot of math. You just start doing it. You do it more and more, and eventually you start learning more and more, and then you get good at doing that thing. Um, that's kind of the secret. I think the the thing is that like I'm not learning math because I want to learn math. Like I'm usually learning math because I have some goal in mind, or I want to get to some end result, and then that's just kind of the pathway that I take to get there. Um, so almost always my learning is motivated by some project that I want to realize. Um, it's not always the case. Sometimes there's a few things in math that I want to look into just for fun, but that came later. That's not something you tend to get like early on. Like geometric algebra. That's a good example of something that was not super useful for my work. I just wanted to look into it because it was cool. Okay, all right. I should really stop the stream. Do I have anything I want to plug? I do. Hold on. How do you get into stuff? Do you read Wikipedia, blog posts, watch tutorials? Yeah, usually a mix of searching for things online. Wikipedia is usually a good starting point. Do you think math is universal? Yes. The syntax is not though, so the syntax would vary depending on who's discovering it, but otherwise, like math is very, very universal. It's like it's a study of like structure, space, and change. like it's hard to think of a universe where those things don't exist. So I can pretty confidently say that it's universal. Based on your experience, how hard is it to create something like a very simple Rhino 3D modeler? Very hard in general. Depending on how much like external code you pull in. Like you can probably make something relatively quickly if you use someone else's, I think it's called a geometry kernel. But in my case, I'm just making my own. So maybe you can take a few shortcuts by using other people's geometry kernels, but which I think is common in CAD applications. But anyway, I should really get something to eat. I'm very hungry. Thank you all so much for joining. I hope this was interesting or educational or good background noise. I have no clue what things people are watching this for. But I also want to link my Patreon in case you want to support the whatever it is I'm doing. Patreon is probably the best place to support my work because they take the smallest amount of percentage compared to every other platform. So yeah, if you do want to support me there, feel free to do that. And on my Patreon, you actually get almost nothing. So I have very little exclusive content. Pretty much everything I do is free and public. And so that's my pitch for for supporting me on Patreon. You get nothing, but you do get to support me and my cats and my projects, whatever they might be. But yeah. Thanks for joining, everybody. I will see you all next time, and I don't know when because I don't have a streaming schedule, but we'll see. All right. Bye-bye.